warns me, the warning given by the waterman of India, Aryabhatta Singh. He says that if the Biharis, they continue with their present side, present psychology, that they have plenty of water, then I think the days are not far when the Bihar will be like a desert like Rajasthan. So we all that wanting, always haunts me. So seeing all these things, I found a very right opportunity to invite him to throw light on what is the present condition of our aquifer, the groundwater, and what is its quality. And actually, this lecture is in continuation with the Earth Day we had observed since he was not free to present his paper. Since that time only, I wanted him to deliver his lecture on this. So he did not have time, he was in Delhi. So now he has found time and he is with us. So the CGS and the Aryabhatta Knowledge University extends warm welcome to him. And I ask my student Kritika to present a bouquet and welcome him. Swati, you take it. And now she's presenting the bouquet to our registrar, sir. And Professor Alex, ex Pilot Vice Chancellor of Patna University and Aryabhatta University. That's one of the things I'm sorry that I haven't the presentation is very nice. Very good activity. Who wants to come on? So yeah. He was recording it.
Mike. Well, good morning, everybody. First and foremost, I'd like to express my gratitude to Madam Poornima Shekhar Singh for having me here. In fact, it was a few days back that she gave me an inkling about this program, that she would like to have a program. And we had done a similar program when she was at Anugrah Narayan College. And it was a very large audience of students who basically had to deal with the subject of geography. But having said that, I must also confess that it's a golden opportunity for us also to be talking on an interdisciplinary approach, because today we can't confine ourselves to a particular discipline. There's a lot of subjects which actually come together in solving a problem today, and therefore geography and geology have a very important role to play together in terms of dealing with such problems. So, having said that, please allow me to tell you a little bit about the organization that I represent. Well, I'm director with the Geological Survey of India, which is primarily an attached office to the Ministry of Mines, Government of India. So we are a very long organization. It was founded way back on 4th March 1851. So it's been a journey of 173 years that we have traveled on either side of dates of independence. So it was primarily founded by the East India Company way back in 1836 to look into the coal resources, basically as a supply material for the railways. But with passage of time, it has really digressed its work into different fields of mineral investigation programs. And if you can relate to this, all the major economic finds of the country have been primarily a contribution of Geological Survey of India. And I would also like to add here that today the topic that I'm going to deal with deals with groundwater resources. Now, we are not the custodians or nodal agency to deal with such programs. And it is a different organization called Central Groundwater Board, which comes under the Ministry of Jal Shakti, Government of India, who actually look into the groundwater repositories as far as that aspect of investigation is concerned. But having said that, I must also confess that we are doing a number of programs across missions. We deal with mission 1, 2, 3, and 4. And likewise, these investigations relate to all those missions. So all those programs of societal relevance, for example, urban town planning, to deal with arsenic contamination, to deal with other deleterious elements in other elements. So these become very, very important. And there the groundwater role comes into play. I would also like to introduce my younger colleague, Mr. Abhishek Kumar Chaurasia, who incidentally is a geologist, but he's doing his PhD in groundwater program. So in fact, he has submitted his thesis on that. And therefore, I'd like to dovetail my presentation with his approach to what he has done as far as the PhD program is concerned. He has already submitted his thesis, and most probably it's going to be awarded very soon. So he's is quite an authority in dealing with the subject, and therefore a particular segment of my presentation that is to do with groundwater quality, he'll be dealing towards the end of the presentation. So that will be a good opportunity for the students to learn. So on that note, I extend my regards to Madam. Once again, I also welcome and express my gratitude to our special dignitaries who are present, especially for this lecture. And thank you very much for having me here as a part of this extramural presentation to deal with the presentation I'm doing with. Well, the first slide is slide mode. Right. So this is a much better view of what we want to see. And well, because I'm dealing with, I'm not dealing with geologists, I'm dealing with geographers. So it's mandatory on my part to make a comparison between the two subjects. Well, there's not much of a difference, particularly at the school level, there's not much of a discrete difference between geography and geology. Because whenever we deal with landforms or geomorphology or physical geography, a lot of aspects of geology come into play. But I think the major difference lies in the fact that the perspective with which you understand the various terminologies and its implications is slightly different when you compare it with the expectation for a geographer or a geologist. So geography, as you can see, is an encompassing discipline that seeks all the major understanding of Earth, inhabitants, natural complexities, and how they've come up to be the way we look at in the present scale of time. But yes, there is one aspect which is quite closely related to both the subjects, is the control of time. Time is very important because whenever we unravel the geological time scale, which has to deal with millions of years, we are doing with certain aspects of present study or the observations which are making today and trying to unfold it in the times to come when it actually happened or when it probably came into existence. Similarly, geology is something which we deal inside Earth. When we deal with the solid crust, whether it is to do with Earth or extraterrestrial planet or Mars or anywhere where rocks are basically the building units of Earth, is something that we start our observations or our study as far as geology is concerned. Next slide. Well, I've also tried to make a small comparison between what geology and geographer does, right? So the word geo is common in both terms, geography and geo. So geo basically means Earth, right? So it is related to Earth. So there's not much of a difference as far as the three letters is concerned. But graphy is to draw the Earth restricted to the surface. And as far as geology is concerned, it is the study of to understand the Earth's processes, how they have come to be, and basically the internal constitution of the Earth. And that is where we go beyond the understanding of somebody who is looking at the superficial part of it, right? So we try to look into some of the questions. Maybe how far is the river? Is question of interest in geography. But what we know like to know in the subject of geology is how and when the river is formed and when the river gets its water from. So that's very important. We would like to be interested that what is the source of that river, how it has come into being, and what are the various geomorphological agents which acts on it. Similarly, how high is the mountain is a matter of interest. But we would like to know, as far as geology is concerned, that what has been the source of orogeny, what constitution makes it, and how long will it remain as a mountain. That's very important. So the perspective of understanding of a similar question in geography and geology somewhat gets different. And that is where the interest between the two subject lies. Next slide, please. Okay, let's come back to the topic of discussion today. And there are three very imaginative pictures out here. One is the picture of our subcontinent, that is India country. And you can see there are a few wells which are going deep into the India. It's a very good symbolic representation of groundwater depletion. As you can see, if we imagine India as a repository of groundwater, obviously the conditions are quite fertile as far as the Indo-Gangetic plain are concerned. But when we go towards the southern part of it, where there are more of rocky uplands and more of rocky repositories of aquifers, then the problem lies over there, right? So if we consider our India as a well, then probably we are trying to obtain water of it, and it is not in a state where we can feel very confident about the future, because it is constantly depleting, and a time will come when probably the well will the drafting mechanism will not fetch any water out of the country, right? So you can see one of the paddy fields right there. So it is a case of deep boring, and it is an important source of irrigation facility that is being provided over there. Now, if you look at the map of Bihar, we have a median drainage over here, which is Ganga River. Now, Ganga River flows from east to west, and it has a certain pattern of north-south oscillation also that happens within the riparian districts of along the sides of North Bank and South Bank of Ganga River. So if you look at the northern part of the river, there are about 18 districts on the northern side, but the drainages are flowing from northwest to southeast, and they're finally debouching into River Ganga, whether it is Baya, Mahi, Gandak, Bagmati, Adwara, Kamla, Bagmati, Kosi, and all these rivers, they have a trend from northwest to southeast, and they ultimately meet Ganga River. So basically, these rivers are coming from the upfront, that is the mountain system, and they're finally meeting the Ganga River. So what is happening? We have a very good relief as far as the extrapeninsular side is concerned. Moment it reaches the Indo-Gangetic plain, the gradient decreases, the carrying capacity of the rivers decreases, and the load carrying capacity also decreases, and ultimately it all accumulates enormous silt which is being brought into the North Bihar plains. Next slide. This is Patna. So Patna is at a very strategic position. It is drawing water and sediments not only from the northern side, but it is also drawing water from the southern part. Next slide. So if you look at this map, there is a separate segment of rivers to the south of it also, which have a slope from southwest to northeast. So you can see it's almost forming a mirror image between the two sections of the river. So Ganga River happens to be the median drainage, and there are certain set of rivers which are flowing from the rocky uplands, that is the Chotanagpur Gneissic complex, whether it is the Rohtas Plateau or the Kaimur Plateau or the Bihar Mica Belt or the Rajmahal Tract. They are all bringing rivers into the system. So what do these rivers basically do? They receive certain amount of precipitation from the atmosphere, and finally, after the surface runoff which goes into the Ganga River, there is a segment of it which goes inside the earth, and that forms a repository of groundwater. So this river systems, these bulbous and enormous river systems with huge amount of water, are a great contributing source as far as contributing to the groundwater conditions is concerned. So you can see the trend of the rivers: the Son River, Falgu River, Mora River, Kyul River, Chanan River. These are the major rivers which are flowing into River Ganga. As you can see, what is the typical trend that you see out here? Can you make an observation out here? What is happening to most of the rivers which are flowing from southwest to northeast, and what is happening to them? Can you make an observation here?
Yeah, after reaching close
yes,
by,
close to Ganga River, there is something unusual happening. What is happening?
They are close parallel.
Absolutely correct. Madam was very quick on making her observation. It is flowing absolutely parallel to the Ganga River. So why is it doing so? It is doing so because Ganga River is also flowing a very significant lineament, and because of that, there is a trend of these rivers to align parallel to Ganga River. Moreover, the second major reason, as far as the geographer would like to see, is that there is a strong levee system, which is a height which is more than the height which lies to the south, right? The peneplain surfaces. And as a result of that, it cannot directly make an angle at a right angle to the Ganga River, and therefore it travels some distance parallel to the Ganga River and finally meets at a level which is appropriate to the flow system, right? Next slide, please. Okay, let's get some basics right. Not much of course, you all are much aware as to what the groundwater conditions are, but some of the important terminologies that we deal with on a regular basis is something important in order to come back to our topic of discussion, right? So what is groundwater? It is the water that lies beneath the ground surface, filling pores and sediments and sedimentary rock structures and other rock types. So what is the typical water cycle that you're seeing in this section? What is happening is that in an intermontane valley system, a lot of precipitation, orographic rainfall is happening, and there is a constant relief which is seen in this particular section. What is falling? It is forming a lake out there, and according to the relief, it is flowing and is forming a part of the river system, and finally it is taking a part of a larger water body which is called the ocean. That is called the surface runoff. That is getting liberated and finally going into the major ocean system, right? But there is a segment of water which is going inside the earth also, right? And that is sprinkling, infiltrating in a very resupplied slow form, and ultimately it is much more cleaner because it has to travel or it has to maneuver a certain section of the earth crust which acts as a filter, right? So it's going and taking place in a particular section of the earth crust, which is conducive to storage of water, and that becomes the storage of groundwater as far as ground is concerned. And the rest of the water is flowing into the river system, and as part of the evaporation process, heat system, it is forming a part of the water cycle. So you've studied water cycle also. Now, if you take a similar section of earth, if you see, and if you see the datum level, there is certain morphostratigraphic expression inside the earth crust also. There could be a sequence of soil, there could be a sequence of sand, and there could be a sequence of sand and gravel, layers, clay, and finally. So we see inside the earth in a section, then we can draw water in certain repository which lies inside the earth in the form of certain drafting mechanism. So that can be in which way? That can be in the form of a duck bill. So when you are doing a duck bill, you are going to a depth of say 10 feet or 12 feet. So you're certainly intercepting the piezometric surface or the surface runner or the water table, and suddenly you see water and you draw water out of it, right? But when you're not able to draw water enough from that portion, you try to go deeper. That is from a subsurface tube well, which is of a lesser depth, right? So the shallow surface tube well goes here and it intercepts a reservoir and finally draws water from there. But if you even don't get water out there, you go to a much deeper section which has been filled over a very long period of time, and those we understand as fossil aquifers. Why do we understand as fossil aquifers? Because these are the aquifers, madam, which have founded way back after the last glaciation period took place. That is between 24,000 years and 13,000 years. That was a time when the water table was at a much higher place as compared to today, and those are the fossil repositories which are found over there. Now, if you're utilizing that water, if you are making use that water, obviously this has taken a very long time to fill up those reservoirs. So those are very deep aquifers. But if we finish them, if we draft water at an unprecedented rate, then probably we'll not be able to fill those aquifers during a lifetime. So that becomes very, very important to save those aquifers and not the aquifers which are lying close to us, right? Next. Okay. All this all clear in the slide. Can someone please react to it? That's what is the basic constitution, or what is the percentage of groundwater that we have in the earth as we talk in terms of global perspective? What is the percentage? It's all there in the slide, but if you can still react to it, tell me.
0.00 something percent. 0.003%.
Right. The percentage of water that lies beneath the earth is on a very meager share as compared to the total water storage or the total water repository that we have. We clearly understand, we have studied in our for formative years also, that's about 70% of the water, surface water that lies within the oceans. As a part of the ocean system, but that is brackish water, that is saline water, that cannot be brought to direct use. So we have to look for water which is conducive to potable means, which is conducive to irrigation, which is conducive to drinking, right? So if you look at this histogram, we have about 97% of the ocean water that is present is in the form of saline water. It's only 3% which constitutes the fresh water. Out of this 3% also, it's about 68 to 70% of the water that is locked in the ice cap, whether in the Arctic region, whether in the Antarctic region, or in the permafrost region. So it is all locked. So only when the temperature rises, they melt, otherwise they remain as it is, above the snow line. But when we talk of the groundwater, it is the remaining 30% of that little share of percentage, that is only 3%, that is available in groundwater. Even out of this, about 87% lies in the surface water. So probably we have a misconception when we see number of water bodies, a number of rivers, a number of lakes we see. All the water lies here, but a much larger volume from that is actually what is the water which we cannot see. There is a certain system of water beneath this building also, but we are not able to see. So we only appreciate that which we are able to see with our naked eyes, but that is not the case. It is a good percentage of water that we have that you see on the surface, but there is an even larger percentage of water or volume of water that lies beneath the earth in various aquifer level systems, right? So it is that system which we are trying to deal with, and that forms the backbone of all irrigation processes, as far as a tropical country like India is concerned. So water cycle we've already understood. Now this is an accumulated precipitation in millimeter of a particular segment across the globe. Now what is the peculiar feature that you see here? Can you make an observation quickly? What is it that you find from here? What is happening here? Is there a particular belt that higher amount of precipitation is happening? And if yes, what is that belt? Sorry?
Equatorial.
Right. And so what is the degree demarcation of that?
5 to 5. 5.
Right, it's quite visible out there. If you see, equator is already written that. So all the red portions that you're seeing, all the blue portions are the seen, where precipitation ranges to about 2,900 to 3,000 millimeter. Whereas all the white portions or the lesser green portions are the areas which are actually deficient in water, right? In terms of precipitation that we are having. So it is the equatorial belt or the tropical belt, the Tropic of Cancer and the Tropic of Capricorn, up to 30 degrees north of equator and 30 degrees south of equator is the belt which is actually abundant in precipitation. So therefore, it forms the most fertile belt and most amount of water or the most surplus water repository that lies in that particular belt, right? Next slide, please. Okay, so what is water table? Can somebody tell me what is water table in plain simple definition? What is the brown area that you're seeing? Right, brown area from the top of the layer is whenever you go outside, when you go in the field or wherever this vegetation and crops are there, you see a certain segment of clay, right? So clay is an impermeable fraction of earth, right? It doesn't allow water to move through it. So it is not a repository of water, right? So you have to look for a conducive media which can support presence of water. That happens to be sand in any form, either minor form or coarse sand or sand mixed with gravel and all those. So brown region is basically the vacuum zone, which lies within the zone of aeration, right? After that, you intercept the first level of water table, which is called the piezometric surface, and that happens at a level of say 3 meters to 5 meters, or maybe it can vary in post-monsoon and pre-monsoon condition to a deeper level, right? So this is basically the vacuum zone, and water level at surface of most lake rivers correspond to the local water table. So what happens? Sometimes you see, even in non-rainy season, your surface water suddenly gets filled up with water. How does it happen? It so happens because at that particular junction, the water table gets daylighted. When the water table gets daylighted, it adds to the surface content of the water. That happens in water surplus regions, but that doesn't happen in Himalayan region or region where the water is at a deficient level. Similarly, so what is the basic difference out here? So above the water table, all the pore spaces that you have a certain amount of air residing in it also. That is called the zone of aeration. But the moment you come beneath the water table, it is mostly filled with water and very little amount of air, right? So that is the basic difference. But sometimes when you have not intercepted the main water table, you might intercept a zone which is called the purged water table. What is the purged water table? Can somebody tell me? Purged water table is basically a temporary mechanism of storage of water, which has happened because of the presence of certain material, a geological material, so to say, which is basically a good repository, but is not able to infiltrate, let the amount of water pass through it, right? So the permeability is less, for example, shales of clay, but that is a local feature, right? So we sometimes make a misconception about the presence of water table. So you must do some wells or must do some exploration at different levels so as to ascertain the right level of water table, right? So it is only a first condition. After you go beneath that, you might find a zone which is unsaturated, right? Next slide. Okay, as far as rocky aquifers are concerned, what do you have to say about it? About 70% of the surface area of India is under rock cover, right? Rest is all alluvium. When we talk of the Indo-Gangetic plain, it is only the alluvial aquifers, particularly in the belt of UP, Assam, Bihar, Punjab, and these agrarian states, riparian states, which are basically dominated by alluvium. But beneath that, it is all the continental landmass, right? It's rocky iron. So those are the difficult areas where water doesn't easily reside. So you have to look for a rock which is important in terms of its storage as a good repository of water. So what do you find in this particular diagram? Can somebody tell me? There's certain infirmities or rocks or fractures or maybe faults in the residing inside a rock, right? So when you actually do a well in a massive section of the rock, which is free of such infirmities, there are chances that you might not find water. But when you do it at a place which is actually a crisscross arrangement of number of fractures happening there, then there are chances that you might find water in there. It happens in tunneling, madam. Whenever we are doing subsurface tunneling, sometimes there is ingress of huge amount of water coming from nowhere, which will absolutely till the last blasting was done. And sometimes it's very difficult to deal with such water. So we are actually dealing with the rocky aquifers out there. So suddenly there's some fracture system which is contributing, which is acting as a repository of water. So that is the difference between alluvium aquifer and a rocky aquifer, right? So confined aquifer and unconfined aquifer, obviously you know about it. When there is an unsaturated zone and a saturated zone, there could be a superficial feature like a lake or a river. And that is happening in a confined aquifer, that there is no confining bed at the top. There is some infiltration. And whenever there is certain drafting or drawdown in water, that has a tendency to get replenished fast. For example, if water table gets affected in a pre-monsoon status, there is chance that it may get reclimatized during the post-monsoon season, but it doesn't happen with the deeper aquifers because there are certain aquitags or confining beds that lie over there. So for the water to actually reach that depth takes a lot of time, takes a lot of infiltration, it takes a lot of precipitation. So we are basically sensitized about this particular zone where water table is getting reactivated because of a good precipitation that is happening. Next. As I was talking about the daylighting of the water system, that is the water table, you can define a few terms which is called the gaining stream. Now what happens in the gaining stream? It is a typical case of intermontane valley where there is a water divide in between and two mountains are providing water through the tributaries or ephemeral streams that are going into they're feeding the lake system. So what is happening? The gaining streams receive water from the saturated zone and gaining stream surface is local water table, right? So they get exposed as far as the water table is concerned. Whereas a losing stream is that there is a conspicuous zone of unsaturated zone lying beneath that surface water and they lose water into the system. So when you lose water in the system, it's called the losing stream. When you gain water, it's called the gaining stream. And there could be a chance when actually the surface body may get detached completely from the water, beneath water system, and then the surface water will dry completely, right? Next slide, please. Okay, basic understanding, drawdown. How do we calculate the drawdown and what is the basic phenomena of drawdown? Whenever, in a typical section when you're seeing this, you're doing a well out here, right? But you're not drafting water out of it. You're doing a well out here, but it is not pumped. There is a well out there. That means the water table is maintained, right? But the moment you drew a well out there, you start pumping out of it, right? To meet your requirements. So there's a time comes when the water table actually goes down to a deeper level. So the difference between the original level and the level that you have achieved as a result of drafting is basically the drawdown that you're looking at. So this is a matter of interest for the hydrogeologists, and that is how they calculate the total drafting that has taken place and total loss of water that has taken place. So this is a primary that can be expressed with the help of open well system, tube well, whatever, right? So you can see the basic conditions. Sometimes it so happens that under local pressure conditions also, a very deep well also can suddenly start giving water. That is called a typical artisan condition. As you know, there is increase of geothermal gradient with depth, that is increase of temperature and pressure, because they're in an overlying section which is adding pressure to that area. So there can so happen that under normal artisan conditions also, deeper aquifers can suddenly supply water to the surface, as it happens in some other regions. Next slide, please. Next. So what are the implications of drawdown? Water is adding certain buoyancy to the surface. How is it doing? As if there are certain void spaces which are completely filled with water, that is actually behaving as a cushion in between. But when you remove that water, all those void spaces start sinking. So many times you would have seen in Himalayas, many times you would have seen in the foothill regions also, that there is sudden sinking or subsidence taking place, that a part of the ground is actually going beneath the normal datum level of the surface. That is also happening because of the excessive drawdown of water, or maybe the water has been removed from that region as a result of some source which has daylighted, right? So that's a very important, it has an implication on the ground also. If the water is removed, then that might lead to certain amount of sinking or subsidence that might take place, right? So when you look at the rock type, it's very important because everywhere we are not as, everybody is not as fortunate as we are, because we are dealing with a country which is basically supportive of alluvium aquifer. But when we talk of Deccan traps, that is the laterite section or the basaltic flows or the intertrapians or maybe the granites, they are not good repositories of water. Maybe we'll have to look for them, that what are those rock types which are quite supportive as far as behaving as good water repositories are concerned. So if you look at them, granite, shale, clay, etc. are very low permeable. They do not contain water. It's also the interstitial spaces which are connected to each other and how they can help water permeate into the lower sections is also very important. So any massive body will not be a good repository of water. But all those fractured units, sandstone which are highly fractured or the interstitial spaces are high, then they will act as good repository. But then there should be a source also for it. In itself, they cannot be good reservoirs, right? Next slide, please. Sir, a little bit of, madam, we'd like to go into the historical perspective that how the Green Revolution came into being. This could be also useful for them because whenever they find they're getting to some interview later on, the historical perspective may also be asked from them. Ki, "Akhir hua kaise? What is the Green Revolution? What is the Tube Well Revolution?" So our organization also has a certain role to play because it is essentially the Geological Survey of India in 1851 that it was founded. With the passage of time, after independence mostly, most of these other organizations like MECL, the Atomic Mineral Division, the Central Groundwater Board has actually been etched out or carved out of the expertise which was lying with the Geological Survey of India. So these important wings were created just to give a dedicated importance to that particular aspect of investigation because it was getting difficult for Geological Survey of India to look for all aspects. Right, if you can see, economics like Robert Petro termed the Green Revolution as Tube Well Revolution because with the advent of Green Revolution, the Tube Revolution became so rampant that the entire process of looking for groundwater resources through exploratory drill wells became absolutely the call of the hour. So that became very, very prominent. Now, if you look at the 1920s particularly, GSI happened to be the main advisory in terms of providing information for municipalities, for irrigations, for dams, projects and run the river projects, water resource development projects, all these projects. After the Second World War, what happened? That the Geological Survey of India, because of the necessity of it, created its own division called the Groundwater Division, and it's created the Engineering Geology Division also. So all the major dams that you see in India, where the surface reservoirs are concerned, where they are present, they are basically the repositories of investigations which have been carried out by Geological Survey of India. So we were basically dominated by a European interest at that point in time. The gentleman that you see in the photograph is John Bickle Auden, and he's the younger brother of poet W.H. Auden. Madam, we have heard about him, and he's the younger brother of John Bickle Auden. The main thing about is that in Geological Survey of India, he was the person who was heading the Groundwater Division and the Engineering Geology Division, and he's the last European to enter Geological Survey of India, that is in 1926, and he was the last European to leave Geological Survey of India in 1953. That was after independence. So if you see, after the Second World War, there was an exquisite need of groundwater resources. So moving from the European interest, they moved towards United States of America. And United States of America had certain amount of interest as far as groundwater exploration in India was concerned. So they got into a very ambitious program that was called the, next slide, please. That was called the 0.4 program, and John Truman was president of United States. He signed a treaty, and that was basically a Cold War diplomacy of the United States of America. And they got into the program, and Geological Survey of India became the main entity as far as Government of India was concerned. Now, what did they? They did some 350 exploratory boreholes, sir, and that was done in all the source strata of the country. It was in alluvium, it was in parts of Orissa, Bengal, Bihar, Saurashtra, Kutch, to look for water resources. Now, there was certain interest involved as far as this treaty was concerned, and there was a particular organization called Ralph M. Parsons Company. It was called the Project Elephant. They tried to explore the entire subcontinent. But what they did was that as soon as they found a good repository of water at whatever strata they were trying to investigate, they stopped the investigation, tried to drill at some other place. So that didn't go very well with the Geological Survey of India, because Geological Survey of India was interested to look into the deeper aquifer also, that what are the conditions, that let's do a complete investigation in a particular borehole information and then come out with the entire information as far as that area is concerned. That created certain amount of differences, and then the Geological Survey of India started segregating itself from the interests of the United States company, right? So as a result of that, because the major interest of Geological Survey of India lied in looking into the mineral resources of the country, water became a secondary aspect of interest. So later on, it was finally, Bora Committee in around 1970s that it was under the Ministry of Agriculture that people thought that no, a handful of geologists, about 60 or 70 people, cannot look into the entire resources of the country. So we must have a dedicated department which can look into such resources. So it was first time under the Ministry of Agriculture that under the recommendation of ETA, the Central Groundwater Board came into being in 1970, and it was basically an offshoot or an outfall of the work or expertise that was carried out in Geological Survey of India. Even today, the exam which is taken up by the Union Public Service Commission, which you all appear and qualify, there is a certain segment of hydrogeologists who come out from the same exam system. So it is basically people who opt for the hydrogeologist section that they go in that section. Otherwise, who opt for the Geological Survey of India, they come to this part. So it is as per their choice, right? Next. So political consent. Right. Wells and not dams have been the temple of modern India. We must shift our attention from sources to resources. Whenever we dug a well, we find water. We become, okay, this well is the source, right? This well se pani hamesha niklega, humko mil gaya hai. This is not true. That is just a source and that is not a resource, right? You have intercepted a particular repository of water, but that can dry with time. So well is just a source and well is not a resource, right? So we have to understand this term in perspective of resource and not a source, right? If we look at some of the figures, about 300 cubic kilometers per year is the utilization of water as far as India is concerned. And particularly because we are an agrarian economy, we are an agriculture dependent economy, the requirement of water is much more. So when you compare it with the massive nations like United States of America and China, we account for almost 25% of the groundwater resources in our country. That is the amount of pressure that we are putting on the earth in terms of groundwater resources, right? If you look at the 1960s and 70s, the percentage of interest as far as agriculture were concerned was just lying at about 30%. Ma'am, now it's about 70 to 75% that we depend continuously, completely on the groundwater resources, right? Second, we need to think of groundwater as a common pool resource. The challenge, however, is that the common pool resource is almost invisible. As I said in my first slide, we cannot see water, but there is a film of water which is flowing beneath us also, right? So you must appreciate that. That is invisible, but that is there, and we need to protect them, right? How can you own the water below your land when the water in your well has come from underneath someone else's? So it has no boundaries, right? You have a boundary wall to your campus, so you cannot go beyond that. Neither the other person from outside can come to our level, but the water can flow beneath the ground wall. So that is something that you don't own completely.
You please continue.
Very informative, very basic. You can continue. Okay, so we continue with the presentation. Wells are only the source of the water and a mechanism to access water and distribute it according to needs and often demands. Wells are not the resource, aquifers are the resource. We must bring into our mind that wells are not the resource, but aquifers are the resource. So we have to identify the resources and what is the amount of water that is lying within them, right? So aquifers are underground layers of porous and permeable rock capable of storing water. Now, if you look at it in the perspective of certain numbers, what is the dependence on groundwater? Just look at the figures on the point number 7. It's about 90% of rural India's drinking water needs is met from groundwater. That's a huge proportion of water. 90% of groundwater, rural India's need lies with the groundwater. And we talk in terms of the requirement in irrigation sector, you can see about 75% of agriculture is groundwater based. 75% is a huge dependence on groundwater, right? And
yeah, I just would like to interfere here. I just want to share my experience.
Yeah.
Once I happened to go to Netherlands, and we were with a local woman, and she was telling us, that they don't draft groundwater for drinking purposes, and it was so mind-opening for me. That how come we are such a big fools that we just do not give any importance, attach any importance to the groundwater, and we are so exploited for the industrial purposes also. We are not using the groundwater. It was really a big surprise for us, for real estate. Because at this stage, I opened the mouth.
very nice.
Those developed countries are not at all using their saving their groundwater. And it's really only big things that we think that it is forever.
Madam, I'll just show a couple of case studies towards the end, where similar studies have been done in Anandpur and Warangal district, and maybe in parts of Chittorgarh. But the precipitation is really low. It's about to the tune of 400 to 450 millimeters per year annual rainfall. There, the requirement of water is so intense that they have to look for alternatives in order to save the water. The point is to save the water, and that is where community participation comes into play. It is not that if I am affected, but the other one is not affected, that will never result in a unanimous approach to a problem. If both the people are affected, and if all the people are affected, then only they will address the problem. Otherwise, they will not do. And soon we will arrive at a time when the problems will become of a much more magnanimous proposition than it is at the moment. We are quite blessed to have the kind of resources that we are looking at, particularly because the upfront headwaters which are coming from the Himalayan section, that is the Shivalik portions and the lower parts of Himalayas, and even to an extent that we have good amount of precipitation as far as this part of the country is concerned. We have a very, very good precipitation, over 1,000 millimeters of rainfall. And if we remember that 2019 September episode, where there was a huge rainfall for 5 consecutive days, where completely Patna was flooded. That was, of course, a frantic or a freak incidence of rainfall. But on an average, if you look from 1970 to 2020, there has been a conspicuous decrease in the annual precipitation. So precipitation is going down. So we have to save water. Have to save water. So next. Okay, hydrogeology, very important. You must have an understanding of what kind of rock types occur in which part of the country, right? So as far as we are concerned, we are a part of the Indo-Gangetic plain. So there is rock inside, but there's a huge voluminous volume of sand, silt, gravel, and intercalated sequence which lie on top of that rock. So basically, all the rocky uplands that you see in part of South Bihar, that occurs as a promontory beneath the huge colossal cover of alluvium. So we have a cushion of alluvium on top of the earth, which basically acts as aquifers, and that is quite huge. In certain sections and the part of foothills, or even parts of North Bihar, that section goes up to as much as 1.5 kilometers to 2 kilometers. That is the thickness of alluvium that you're looking at. So that way we are quite fortunate because alluvium happens to be the greatest repository for all kind of aquifer conditions, right? So these are the broad lithology that you see. All the red portions are the crystalline rocks. The yellow portion that you can see out here is part of the Indo-Gangetic plain, comprising parts of UP, Bihar, Assam, Uttaranchal, lower part, that is all the foothill regions. If you look at the brown regions, that is in between patches, these are the aquifers in the hilly areas, and the green portion, which forms the major part of the Saurashtra region and the Maharashtra region, is basically the laterite or the Deccan traps, right? So this is basically the constitution of the slide, correct? So I talked about the fossil aquifers. It's very important to identify the deeper aquifers. Deeper aquifers, and to preserve them over a long period of time, because these are aquifers which have formed during the last Holocene period when there was maximum glaciation. We are yet to see another glaciation period. आप लोग तो geological time scale जानते हैं ना? We have already seen the last glaciation, and we are actually thriving in an interglacial period, right? So that also coincides with the human age where we all enjoy this. But actually, a time will come when a major glaciation will take place in future, whenever it happens, right? Next. Dependence on groundwater in urban areas. Wherever rock units are present, man, whether it is basalt, whether it is crystalline rock, whether it is massive rocks, there is huge dependence on surface repositories. Why? Because they are not good repositories of groundwater. Moreover, in order to draft water from a thick, consolidated, rocky section, it is always difficult. How can you do it? You can easily puncture a bore well into alluvium, but how can you do it inside a rock? It's very cost. There are cost implications as well. So it's not very easy. So in all those areas, about 75 to 92% dependence is on surface water. And where do they get the surface water from? By saving water on the surface. Only when they save water through mechanism of water harvesting system, through ponds, through lakes. I will just take you the case study, which is very, very encouraging in terms of how people in our own country are dealing as far as the southern part of the continent is concerned. Right? Next. Surveying 310 cities has clearly brought out this fact that surface water dependency is great as soon as we go beneath this level, right? From this level down below is where the surface conditions of repository are much more, because the draft from the underground sources is not much, right? Next. Okay, आप लोग को थोड़ा सा figures याद रहेगा, तो you might relate it because there can be some objective question or some competitive exam that you might take up, right? So these are basically porous formations which are unconsolidated and semi-consolidated, and unconsolidated formations basically comprise of cobbles, ferruginous nodules, and older alluvium. What the basic constitution of Bihar region, right? So if you see in the Indo-Gangetic plain, what you can see, the draft is more than 40 liters per second. That is the draft which you are getting from the Indo-Gangetic plain. Suppose you do a well or a tube well, then the draft can be as high as more than 40 liters per second. But similarly, when you go downwards, it is decreasing in patches of limestone. If they happen to be cavernous, that means they're interconnected through spaces, then the repository could be high or the drafting could be high. But generally, it is found in the range of 5 to 25 liters per second. Now, if you look at the crystalline rocks, that is the part of the cratonic shield area, the draft gets even less, 1 to 40 liters per second. That means you are not getting 40 liters per second. You might as well get 1 liters per second also. So that is the range, right? So similarly, if you look at the basalts and laterite, it is even lower. That is the main reason why Maharashtra always has problems of water. The rivers that you see in Maharashtra, ma'am, all these rivers, they are very thin. The span of the river is very less. It is not more than few meters, 10 to 20 meters. Even water which is flowing in them, it does it like a small film of water. It is relegated either to the left bank or the right bank, or it is completely gone during the summer seasons also. So that is the point where they try to save water, right? And when you talk of the alluvium and the sandstone region, particularly the desertic conditions of Gujarat, that is the area where it is about 10 to 40 liters per second, right? Next slide, please. Interested in this? This is the geological map of Bihar.
Yes.
भाई मेरा तो सब्जेक्ट जियोलॉजी इसके बारे में हम थोड़ा तो बोलेंगे इसके बारे में. So you must have an information about the geological framework of Bihar, because as a student of geography also, you must know your state. What are the geomorphic expressions? What are the geological? So when we talk of Bihar, the segregation into Bihar and Jharkhand took place on 15th of November 2000, year 2000, Y2K. On the turn of the century, both the states were divided. That was rather an unceremonious segregation, because most of the mineral resources, most of the rock units went to the part of Jharkhand, right? So as on today, it is about 92%, 92.7% area is within the realms of alluvium, right? So all this area that you can see, the yellow portion, all this portion is completely alluvium. So what are the rock units that lie? Next slide, please. Okay. So water system, as I talked to you about the hydrological divide that forms, that Ganga River forms in between, median drainage, we have a flow system that comes from the north to south, similarly from south to north to south, right? Next slide. Next. So C. What is C? Can somebody identify this? I'll ask a few questions also, ma'am. Right. So what is the C area? Can somebody tell me? Because when I ask questions, you'll remember it the next time.
Sasaram side.
Very good, very good. So basically, that is the Rohtas plateau, right? So plateau region, the height ranges from about 100 meters to about 650 meters, but that is mostly in the form of plateau, right? It is not a hill, right? It's a plateau because it's a bedded sequence. Bedded sequence formation, limestone, shale, sandstone, glauconitic sandstone, fawn limestone, and all those units which have actually formed in the part of the Windan succession, right? Next. What is this? Very good, very good. What's your name? Saurabh. Very good. So this is a part of the Rajmahal Traps, which is basically an intertrapid sequence of flows and basalts which rise to the east of East India tectonic zone. So there is a conspicuous lineament called the EITZ, along which that particular deposition has taken place, and it is very much a part of Poornima sedimentation, though there are different school of thought which says that Rajmahal is a separate sequence because that directly overlies the Dubrajpur sandstone and the Barakar sandstone over there. But it is a layer of continuous trap which are good repositories of minerals. Next. What is A?
Possible.
Right, possible is okay, but it is basically the Neogene quaternary sequence that lies between the foothills, right from the boundary of India and Nepal, down to the Chotanagpur-Gneissic complex. So it is, I'm talking about the entire alluvium sequence that lies over there. It is a part of the Neogene quaternary sequence, and it is further accentuated by the sedimentary flow of major rivers, which are flowing from the Himalayas and which are flowing from down below from the rocky uplands of Chotanagpur-Gneissic complex. Next. B. What is B? Very good, very good, very good. So this entire belt of Chotanagpur-Gneissic complex, right from here, it is just only a part of the massive belt, which is a part of the central Indian tectonic zone, which is continuing from parts of Madhya Pradesh, parts of Jharkhand, where it is more pronounced, and only a certain part of it is now left in Bihar. But these are very good mineral resource belts, right? Next. Okay, what is this? Very good. Very good. Someshwar range. So there are basically three formations: Someshwar formation, Kamarchiba formation, and Boulder conglomerate formation. This is a part of the lower and the middle Shivaliks, and that is called the that's what is the lower Himalayas, right?
Yes.
And after that, the Piedmont zone starts, and after that, the Foreland basin starts, where this thick alluvium exists, right? So can somebody tell me what is the normal height of the Shivaliks? General height? If you have any idea?
1500.
Sorry? Average height?
1500 meters.
Very good, very good, very good. So these are low height mountains, right?
Mm.
So when you go into the middle Himalayas or the higher Himalayas, the height keeps on increasing. When you talk of the Mount Everest, the height is 8648, right? But Shiva, 884 is right. So the Shivaliks is something that doesn't go beyond 2000 meters. The highest point in Shivaliks lies at the range of 2000. That's a very good information that you have. Right, next. Okay. I've already talked about this, the Rajmahal sequence, of course. Some investigation of GSI is also going on there. Very good repositories for coal and intertrapian fire clay sequence, where we are doing some drilling work out there and we are getting some very good produce. Madam, I would like to also inform that Bhagalpur was not investigated earlier, that we are doing investigations in Bateshasthan and Kehalgaon area for the fire clay sequence. And we are doing about 10 boreholes over there. And we are also finding coal at the lower level, at about 75 meter to 80 meter. That means that the entire Rajmahal tract or the Gondwana sequence actually goes up to the level of Bhagalpur. So that's a good new find. So we have something to feel excited as far as Bihar is also concerned. Because some coal reserves have been found over there. Of course, the quality is not very good, but still creates interest in the market. Next. What is this question? Can you tell me? This one?
Mica belt.
गोल्ड है ना गोल्ड
नहीं हम कमोडिटी की बात नहीं कर रहे हैं हम जनरल सेटअप के बारे में बात कर रहे हैं हैव यू हर्ड ऑफ द गोंडवानास
Yes.
गोंडवाना आप जानते हैं सैंडस्टोन शेल होता है देयर रिपोजिटरीज ऑफ कोल बहुत होता है तो जहां पे आपके क्रिस क्रॉस फ्रैक्चर बेसिस होते हैं वहां पे लेटेस्ट सेडिमेंटेशन होता है गोंडवाना बेसिस ऑफ कोर्स इज अ पार्ट ऑफ द मेजर विंडियन सेडिमेंटेशन ठीक है वेयर इट ऑल फॉर्म्स अ रिसेप्टिकल ऑफ फाइल सेडिमेंट्स बट ये कहीं-कहीं पे एक्सपोज्ड है विद इन द छोटा-नागपुर नाइसिक कॉम्प्लेक्स सो इफ समबडी सेड that you're finding Gondwana near Aurangabad, don't be surprised, it is possible. Yes, they occur. This is a fact which many people, many known people also don't know about this, that Gondwanas exist over there. And Gondwanas do exist over there, right? Next. ये interesting सा बात आप जानते हैं क्या? ऐसे से निकला हुआ है?
राजगीर का
Wow, very good, very good, very good. So Rajgir is basically an arenite glacier sequence of quartzite and phyllite, but it's a very interesting find to the northern face of the faulted face of Rajgir map, where we found a volcano-sedimentary sequence that is basically a continuation of the Mahakoshal group of rocks which exists in parts of UP. So this was a novel find, and that probably enunciates the mixing and mingling of mafic and felsic magmas, and that is basically a volcanic eruption. So we have got very good evidences of pillow basalt. We have got very good evidences of acid too, pellitive too. We also have banded iron formation. We have good gold occurrences over there, for which we are getting some fire samples of fire assay. Of course, they'll give you the exact value, and some investigation is going on in that area also. And so that's triggered a new point of interest. And there is one presentation map which I'd like to share with you. We have done a presentation on the geotourism aspect of Jahanabad, Rajgir, and Gaya area, where we have highlighted all these features. So I'll just share it with you. That's a very interesting presentation, 19 minutes. And that takes into account this novel lithostratigraphic sequence of to the north of Rajgir. So
बराबर हिल्स भी एक
बराबर भी है वो आपका 3 डोमेन में हमने उसको बांटा है नॉर्दर्न डोमेन आपका ग्रेनाइट्स का है जो आपका जहानाबाद का है तो वहां पे गैप्रोपैराक्सोनाइट सीक्वेंस है जो कि आपका मैग्नेटाइट अकरेंसेस भी है मिडिल जोन जो है दैट इज द वोल्केनो सेडिमेंट्री सीक्वेंस एंड फाइनली द सदर्न जोन इज द राजगीर हिल्स जो कि इट्स अ फोल्डेड सीक्वेंस राइट so the geomorphic expression also tells you about certain feature that lies inside so you can see this is basically a fold which is happening right so आप लोग fold पढ़े होंगे geography में जब से so it is basically a geological term next slide please ये CGC बताइए दिया next हाँ और यहाँ पे पटना है और इस पे हम अब आते हैं next slide okay so water availability in context of Bihar this is a wonderful hydrological map of Bihar in which stevens per centimeter is the hydrological contours that have been prepared as you can see most of the blue region are the parts which are dominated by the presence of alluvium so these are the portions which have high amount of alluvium next slide please now if you see when we talk of the Chotanagpur Gneissic complex basically the granites and the variants and mostly the Precambrian rocks these are the portions where the yield is not more than 20 meter cube per hour. So when you talk of problems, even in your own state, there are areas which are actually deficient in water. The water is not as much. Next.
Modern groundwater system.
Modern?
In the area, like Rakhine and all, they have all you need the groundwater system from the software. Any software needed to show the demarcation of groundwater flow information.
Yes, this is actually based on exploratory borings which have been done in that particular areas. Not only the formations, a number of borings with center groundwater borings done. Right? On that basis, they build a flow model. Obviously, the software I'm not exactly knowing at this point in time. But on this basis, this particular demarcation has been made.
This demarcation is pre-monsoon or post-monsoon.
Pre-monsoon also, there is a map which shows about post-monsoon. So this is a different map. So you cannot mix both the maps. So this is done over a decadal period. So about 10 years, they have seen the entire pattern and how the pattern behaves. Then that is how they have built up the contacts, right? So if you see most of these areas, these are the pediplain and pediment areas. That is the foothills of the rocky uplands that lie to the south of it. So this is basically, apparently you will see that there is certain amount of alluvium or thick clay over there with calcrete and nodules. But beneath that, at a shallow level, you might find rock, right?
So in particular, how many you have board from CTW or state groundwater?
No, state groundwater board करके कुछ नहीं, central groundwater
Central
board सारे
groundwater.
exploratory board. PhD does some exploratory board, but that's for a different purpose on the recommendation of central groundwater.
In average, how many in particular district?
I'll just show you the example of Patna. Patna as a district, we have about along the entire Levi portion, that is the southern face of Ganga River, we have about 91 boreholes already now, exploratory boreholes at different depths. So there's point information also. That is how they build the fence diagrams or the panel diagram, and then they try to match the information. Because there's some non-invasive method also, like resistivity survey, which gives you information on the underground conditions. But borehole is much more accurate. So exploratory boreholes, that mandate lies with the central groundwater, right? Next. So you can see this region, the yield is about 50 to 75 meter cube per hour. Next slide. Next. But if you see the Indo-Gangetic, well, that is the northern parts of Bihar, you can see the yield is suddenly increased to about 150 meter cube per hour, and that is where water is abundant as of now. Next. But there is a very small zone over there where the yield is really less, and that talks about the control of geology, which is so very important. There's basically the calcrete or the contour, the boulder zone, which doesn't allow much water to reside in there. So that is a very small patch at the foothill region that is actually giving a low yield. Next. Okay, let us come down to our Patna. So Patna is located at a very strategic place. If you look at in terms of civilization, it is mostly the big rivers which have given birth to great civilizations.
Yes,
and we always look for water resources or the water bodies to thrive in terms of population. So it is mostly the Gangetic plains that you find the biggest, most populous cities in the world, right? So whether you see it in any part of the world, whether in India, when you talk, so all the major cities are actually on the banks of major rivers because they are a constant source of water, right? So if you look at Patna, despite the strategic position that it enjoys, because we have Gandak River from the north, we have Son flowing from the south, we have Punpun River, we have Mural River, and we have the Ganga in itself, the mighty Ganga, the confluence of so many rivers. But still, we are still thriving on groundwater resources. Of course, they are contributing to the groundwater repository, but yes, our dependence on groundwater is acute. We are not taking water from surface water. We are still trying to look for resources which lie underneath because they are most easily accessed, right? So even strategically, if this happens, and you look at some of the figures, the average annual drought as far as Patna is concerned for various purposes, for potable irrigation and drinking needs, is about 220 million cube, which has caused a decline of about 4.1 meters in the deeper aquifer levels. The amount of drafting is so high, ma'am, that it is not the upper level aquifers which are getting as much affected. But if you talk of the fossil aquifers that lies in semi-confined or unconfined conditions, confined conditions, they are the portions which are actually showing a certain amount of decline. And 4 meters is quite as much if you talk in terms of the whole region as so. Next slide. Okay, these are the groundwater scenario. Of course, this is not our data. This is collected from the Central Groundwater Board because they are the custodian of such investigations. But yes, we did some similar exercise when we were doing some. We were doing the urban town planning of Patna district because it has been identified as one of the smart city contenders along with Muzaffarpur, Bihar, and Mural. So these are the 4 cities of government, right? So when you talk in terms of district, we have a very good association. We have Son River to the west, we have North Ganga River to the north, we have Punpun River to the south, and finally all these rivers are flanking Patna as a district. आप लोग में से कोई बता सकता है पटना किस टोपोशीट में आता है? पूरा डिस्ट्रिक्ट टोपोशीट जानते हैं? क्या होता है टोपोशीट?
गवर्नमेंट ऑफ इंडिया का एक लैंड मार्केशन।
हाँ ठीक है, I'll accept that answer. किस टोपोशीट में आता है जानना चाहिए आप लोग पटना में बैठे हैं। अच्छा आज जान लीजिए। We are standing in 72G/2, right? And we are sharing the boundary with 72C/14, right? 72C/14 comprise all the areas to the west of Danapur, and to the east of Danapur are the areas which come under 72G/2. तो 72G/2 के नीचे कौन सा टोपोशीट आना चाहिए? एक टोपोशीट में 720 स्क्वायर किलोमीटर एरिया होता है, ठीक है? बट ऐसे ऐसे सब टोपोशीट से 16 टोपोशीट से एक डिग्री शीट बनता है, दैट इज कॉल्ड 72L, राइट? सो 72G, तो G में आपके 16 टोपोशीट्स हैं। तो कैसे उनका डिमार्केशन होता है? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, इट इज लाइक दिस, टॉप टू बॉटम, टॉप टू बॉटम, टॉप टू बॉटम। अगर आप G/2 में हैं तो G/2 के नीचे कौन सा होना चाहिए? वेरी गुड। So G/3 में भी कुछ हिस्सा है जिसमें पटना पड़ता है। So this is an important piece of information. Anybody can ask you that आप किस टोपोशीट में काम कर रहे हैं, क्या कैटेगराइज करें, ठीक है? Right. Because that is the landmark, मतलब वो एक आइडेंटिफिकेशन है आपका on the map. So एक normally एक सर्वे ऑफ इंडिया टोपोशीट का क्या स्केल रहता है ये बताइए? What is the scale that you are working on as far as the topoशीट is concerned?
1:50.
1:50.
Sorry?
50,000. 1:50,000.
50,000. Very good, very good. What's your name?
Kritika.
Kritika. And what is 50,000 means?
It means like one inch on the map is representing the 50,000 inches on the ground.
Right. You were slightly incorrect in terms of the unit that you're
हाँ,
using.
unit,
It is not
yeah,
inch.
it's not
Because
inch.
inch is a different scale of map. We are dealing in terms of centimeters.
Centimeters,
That
yeah.
means 1 centimeter on map is equal to 50,000 centimeter on ground. Right?
Yeah.
That is called the fraction or the fraction factor. And 1 to 50,000 map, इसलिए हम उसको कहते हैं, ठीक है? So 50,000 centimeter means 500 meters of ground. So any scale that you see in the map as 1 centimeter will correspond to 500 meters on ground. So that is the scale which you're using. That is the first level map. And of course, we go for modified scales also, and lower scale maps also, and higher scale maps also. So अगर बहुत बड़ा representation करना है बिहार का, we go on a 2 million map, or a 5 million map, or a 10 million map, or a 20 million map also. तो उसी तरह से आप normally एक टोपोशीट आप 50,000 scale में काम, right? Next. So flat relief है, इसके बारे में आप जानते ही हैं, you can just go through it, nothing to go as far as notable geometrical features of a strong natural levee. I was talking about all the rivers actually take a parallel front as soon as they come close to river. That is because of a very strong levee section, which is height, which is above the normal flat relief that they are having, and definitely that water takes a course, and wherever it forms a bend, it goes into the river and meets Ganga River, right? Now the areas underlying by quaternary alluvial formation, comprising clay, silt, sand with occasional gravel. Right? Next. So this is one of the studies of pre-monsoon, जैसा हम पूछ रहे हैं, pre-monsoon, post-monsoon study बहुत important होता है, because that tells us about the fluctuation that has happened prior to rains when it is right, and after the rains after they have gone. Right? So ये एक study हुआ था 2011 में, and this work was again repeated as a part of our study manner during 2019-20 when we were doing Patna urban agglomeration study. Right? So you can see all these yellow areas are the areas which are having the piezometric surface of water table at a level of 5 to 10 meters, which is very less, but yes, other people are not as fortunate, they are not finding at 5 to 10 meters. We are pretty late. So अगर आप 5 मीटर का गड्ढा खोदते हैं, तो chances है कि आपको पानी मिल जाता है, ठीक है? So all these regions, except for a few patches, which is got green and purple region, which is at a higher levels. That means drafting is one or even the geological conditions don't allow water to stay at that particular level. When we take a look at the depth of water table in the post-monsoon season, of course, there have been a certain gain. See, after rains, what has happened? The second section from 5 to 10 meters has actually become 2 to 5 meters. So actually, there is a gain. So that actually the water is accentuated over there. It has gained as a result of precipitation. But this is not happening in case of deeper aquifers. It is only the superficial aquifers which are getting charged or energized, right? Right. And particularly the third section, as you can see, it is more than 10 meters, but here it gets about 5 to 10 meters. So this is normal fluctuation which is happening in most of the cases, but you need to take a good account of this, take into cognizance this aspect also. But if you find a continuous decline in the piezometric surface, then you need to be worried about. Over a period of time, say 10 years or 5 years, अगर आप continuous decline देखते हैं कि नीचे की तरफ ज़्यादा gain नहीं कर रहा है, then you have to be wary of the situation. Right? Correct. Right. Okay. This is geological map of Bihar. Geology तो जानेंगे ना, आपके अंदर में क्या है, नीचे में क्या है. So basically हमारा जो channel alluvium है, that is from the active floodplain sediment. जहाँ भी नदियाँ बह रही हैं, that is the active channel. उसके बगल में आपका पतवा formation है, that is the younger floodplain sediments, and उसके south में in the order of antiquity, we have the older alluvium. That is the source. तो उनका एक morphostratigraphic implication है कि वो particular time scale को correspond करते हैं. That means they are time sensitive. ठीक है? Time. तो ये आप मैं इसको रख भी दूंगा, जरूर उसको स्टडी कर लीजिएगा कि मोटा-मोटी जियोलॉजिकल कंडीशन सरफेस पे कैसा है. नेक्स्ट स्लाइड प्लीज. लैंड यूज लैंड कवर. We decide that what is the kind of water utilization in that area. For example, अगर fallow land है, अगर कोई ऐसा लैंड है जहाँ पे आप काम नहीं कर रहे हैं, तो वहाँ पे आपका ड्रॉडाउन कम होगा. उसी तरह से अगर हाईली बिल्ट अप एरिया है, वहाँ पे डिमांड ज्यादा बढ़ जाएगा. उसी तरह से जहाँ पे एग्रीकल्चर ज्यादा है, वहाँ पे ज्यादा होगा. So you make a very good land use land cover map, and you do it with the help of so many softwares which are available, maps which are available, and you do some field checks also. You go to the field and try to check whether what you have analyzed over from the software actually is matching with the ground conditions or not. So we built up a map of the area, and you can see some of the figures that lie beneath this map is that about 256,694 hectares of gross cropped area lies in Bihar, in Patna, and net area sown is about 201,103 hectares, indicating cropping intensity of more than 100%. That means the dependency on agriculture and agricultural produce is very, very high. So that almost compares with the average state Tal-Indiana areas, which are both monocrop areas. So अगर आप देखें तो इस पर बहुत ज़्यादा dependence है agricultural produce पे. The total area of net irrigation is about 109,000 hectares, and which says that the groundwater irrigation dependency is close to 80 to 82%. Right? Next. Madam, these are part of the studies which we did as a part of the groundwater quality assessment that was done in 2019, 20, 2021. So, a very recent study, and our paper is also coming up very soon. It has been accepted, and my younger colleague is the author, and I'm also a part of it. These are some of the grid sampling that we have done in the area. Entire area we have divided into grid, and we have done sampling from a particular reservoir section. So once you have studied the conditions, we did it at a depth of about 120 meters, because 120 meters is the depth where everybody, even private wells are accessible at that point. Even the Jal Nal Yojana, all these government-aided schemes only go to a deeper scheme when the need be. Otherwise, all what people are normally getting water from that zone. So we have taken into account that particular depth. For all other, we go on for these slides. Next. Okay, so the pre-monsoon, madam, is a very good comparative study between 2011 and 2019-20. If you recollect the last slide, the green one, the water was available at 2 to 5 meters. Just look at the figures, how it is mapped. In the pre-monsoon studies, the blue are the areas where the water exists at more than 11 meters in the same area. It is the Patna area only. And the grey areas are the portion where it lies between 11 to 14 meters. That means in a period of 9 to 10 years, there has been a certain decline in the water table also. That is, there's a trend which speaks about itself, which speaks about the gravity of the situation. Similarly, if you see the post-monsoon season, there is a marginal gain. 11 meters get 7 meters, but it is not 2 meters as it was in 2011. So there is a certain amount of fluctuation which is happening. Immediately after this work, that 2019 episode of huge rainfall occurred, and in 2020 things improved. So we are quite lucky to have that kind of precipitations in a different manner. Next. So if you compare the rainfall versus groundwater level, this is the fluctuation map. What has been the fluctuation between the pre-monsoon and the post-monsoon? And this is the fluctuation how it looks like. More than 2 meters, more than 5 meters, 5 to 8 meters, 8 to 11 meters. So we need to be very cautious at the base of this circle diagram that plot that the red areas or the orange areas or the yellow areas are showing a huge amount of fluctuation. That is the difference between the pre and post monsoon results are quite significant. So we need to be wary of that area. हम कोई भी काम अगर करेंगे वहां पे हम अपने ध्यान में जरूर रखेंगे based on this map, right? Next slide, please. Okay, this is a north-south orientation and the east-west orientation of Patna. As I said, we are flanked by Son River to the west, that is close to Maner, and we have Ganga to the north, and we have Purpur to the south. So this is east-west orientation and north-south orientation. So if we try to understand the assembly of morphostratigraphic build-up inside our Earth, inside the ground that we are standing or sitting on, this is what the section looks like, right? So if you look at this, if this is a particular east-west section, this is north-south section. But basically, at the top aquitard level, that is all the minor bathymetric surface where it lies, the dugways where they exist. Sometimes water is there, sometimes water is not there. But that zone is basically about 15 to 20 meters on the top, followed by the first aquifer level, which varies in depth from 35 meter to 60 meter and at places from 80 to 130 meter. So the thickness of the first aquifer level is about 55 to 60 meter. That is the level I'm talking first. And then there is a confining layer or an aquitard or a clay layer where the thickness, of course, you can see in that north-south section, it's getting thicker over there, the confining layer. The thickness ranges from 99 to 60 meters. So there is a thick sequence of 9 to 60 meters where there is no water absolutely. So when you draft a well over there, you won't find water over there. But when you get to the bigger aquifer, aquifer number 2, that zone ranges between 110 meter to 265 meter, right? So 265 meter is how much feet? Around 600 feet. ठीक है? तो 600 फीट का हमारे पास एक्चुअल इन्वेसिव इंफॉर्मेशन, मतलब कि जैसे आप पूछ रहे थे एक्सप्लोरेटरी बोरवेल से, इज इट एन इनडायरेक्ट एनालिसिस ऑफ द एरिया? नो, इट हैज ऑल बीन सर्वेड. बट बियॉन्ड दिस लेवल, जहां पे नेक्स्ट कंफाइनिंग लेयर आया, मैडम वी वर नॉट एबल टू डू अ बोरवेल more than that, because normally alluvium aquifer में होता है, straight borehole करते हैं तो वो collapse कर जाता है बहुत बार. So a lot of casing has to be used, and to go deeper than that, whether an aquifer condition stays below that, therefore to ensure that we must do a borehole study over there, and of course that can be substantiated with the help of non-invasive studies also, right? Similarly, so second information. So this is basically a constitution of where you are standing, right? तो इसमें अगर आप कभी भी पंक्चर करेंगे तो इसी को ड्राफ्टिंग के बेसिस पे डिक्लाइन देखती है कि कितना मीटर डिक्लाइन हुआ है उसको देखते हैं. Next slide. Okay, this is a panel diagram or a fence diagram, and this is very much a representation in a different manner of the diagram that I have shown in the earlier slide. So the first principal aquifer, as you can see, is 50 to 80 meter. Its thickness decreases at 50 meter in certain portions, and this is represented with the help of this map. So this map is very useful because on the surface, some of the prominent localities have been shown by which you will be able to associate with this locality. For example, if Maner is over there, you can obviously make an understanding that Son would be next to it. Similarly, we have Bateri, Vidyakant, Chaudhara, Wolfner, Garbagaria, Mithapur, Ansan, Khagol, how the basic, and of course, it is not a monotonous sequence, it is a scale that we are basically looking at. बीच में बहुत सारे आपके पतले-पतले clay horizons हैं, जो कि आपको disturb करेंगे, लेकिन आपको मोटा-मोटी आपका aquifer है. All the yellow portions is clay, all the blue portion is cold sand, fine to medium sand, and finally the sandy clay layer. And we have an aquitard layer. Next slide, please. Okay, another diagram will show the same. Of course, it has been shown with the help of a scale. As you can see, we are going to a depth of 180 to about 220 meters, for which we have good information as far as the underground aquifer conditions are concerned. Next slide. These are the lithologs, very important, man. We did some seismic acquisition study in Patna, which even the metro project, which is now running, and we would be very happy to share that information with you. Of course, it is not of direct interest to you, but as far as looking at the seismic vulnerability of Patna is concerned, particularly in context of the 1934 and 1988 earthquake, which is the East Patna fault, which is positive factor. The Japan people who are collaborating with the Patna metro network, they have come to our place. And we have good information on grid basis along X and Y axis. Down the interval is 3 kilometers. We have done about 30 boreholes, amounting to about 900 meters of subsurface information. So that level of 30 meters, we have complete information whether they are liquefiable or not, whether they are how they will respond in a event of an earthquake, and all this information, because that is very important information as far as subsurface structure is concerned. Because metro will be about 70% underground and 30% it will be over the ground. So we are in a sensitive zone in terms of earthquake vulnerability also. So those kind of studies, particularly the standard penetration test, in situ test, cone penetration test, all these values come into play as far as designing your structure is concerned. So we have litholog information, And till date, I believe, having worked in engineering geology division in Lucknow and in parts of Uttaranchal, there's nothing actually equates with a point information. The borehole information, if you are able to log well, if you are able to understand well how the subsurface conditions vary with depth, then you can make very good assessments about the conditions which are lying over there. Next. Water quality index. Of course, my friend is going to talk on this as soon as I finish my presentation, because that is something for you to learn about.
Yes.
Water quality index takes into account a lot of composite factors in water which are present that actually influence the quality of water. Madam, as we always know, we cannot talk in terms of quality, right? Qualitative assessment never gives us a real picture. We must arrive at numerical value to understand a particular thing. That is, of course, based on certain factors which help us arrive at a numerical value or a unit. That gives us a very good understanding of where we actually lie and what could be the problems in that particular bracket range of numerical value that we are looking at, right? So this is the water quality index that takes into account number of factors like pH, the total dissolved solids, the bacteriological content, the chloride, the total hardness, the presence of various elements. And all these things are brought into account, and then we classify it on the basis of WQI, which is there. And these are the segments of percentage which lie there. If it corresponds with any of the brackets that you're looking at, then you can say your water quality corresponds to that, right? So it can be excellent, good, poor, very poor, or water unsuitable for drinking. So that can give you a fair amount of idea about water quality. So water quality is this area of thesis, and we'll just talk about it in detail. Next. Well, these are some of the findings which we carried out as a part of the Patna study, Patna work, Patna urban agglomeration. As you can see, these are the TDS concentrations. We have the total hardness, the nitrate concentration, the EHPS factor of the entire area of about 600 square kilometer in C by 14 and G by 2. And finally, on that basis, what we derived that the water quality index is coming to a numerical value of 73.5. That is averaging of all the excellent, good, and poor values. And of course, there are certain sectors which lie in the critical part or the poor category, but it lies in the 73.5. That is good category water that we are drinking as far as we are concerned. It's not excellent, but there are some regions or there are some provinces within the state of Bihar, so within the district of Patna, that we have excellent water conditions, but there are some inadequate conditions also lying. So this is the good water category that we have come up with. Next. Very important, ma'am. I was talking about arsenic, and we have such a phenomenal contribution in the work of arsenic that we are doing. We have carried out along the Ganga plain, right from UP border, from Buxar up to Maner area. And then we have also covered Samastipur and Bhagalpur. We have done certain portion of Bagha area and Champaran, and we have completely covered Bhagalpur. So what our aim is to prepare a seamless map of the entire basin so that we can have a realistic of how the arsenic contamination, their spatial and temporal control, so that people can be much more informed in terms of planning their requirement of water no underground is concerned. So it is mainly बहुत बड़ा टॉपिक है, फिर हम आपको अच्छे से बता देंगे. आप उस पर घुसेंगे तो बहुत ज्यादा देर लग जाएगा. लेकिन आप मोटा मोटी इसको समझ लीजिए कि geology plays a very significant role, right? Why it plays a significant role? Because the source of arsenic can either be anthropogenic, हो सकता है आपके एग्रीकल्चर बेस्ड में आप ऐसा कर सकते हैं, एंथ्रोपोजेनिक कंट्रोल्स हो रहा है, फर्टिलाइजर्स हो रहा है, पेस्टिसाइड्स हो रहा है, or when it acquires endemic proportions, that means it cannot be rectified in due course of time. A problem इतना बड़ा हो चुका है कि अब वो छोटे समाधान से वो नहीं सुधरेगा, ठीक है ना? तो उस चीज के लिए हम बड़े रीजन को देखते हैं. So बड़े रीजन को एंडेमिक अगर वो नेचर ले लिया है, तो बिहार is one such state where it has acquired endemic proportions. The first ever instances were found sometime in 2002 to 2003, and today, madam, from the infected districts of arsenic, we are getting maximum number of cases related to life-threatening diseases like cancer, gallbladder cancer, lung cancer, and liver cancer. All these cases are really coming up from those areas. And therefore, the work is rather intensified from other institutes also, medical institutes, and they're taking help in collaboration with Geological Survey of India to look into these aspects. In fact, Government of India has also signed an MOU between CGWB and Groundwater Board, ICMR project, Indian Council of Medical Research, Japanese team, the British team, they're all coming to Bihar to study this problem. So, I would really like to make a separate presentation on that, because that is a separate aspect altogether. But मोटा-मोटी अगर आप समझ लेते हैं, तो ये गंगा है, right? and it is flowing from east to west. So अगर हम over the passage of time देखें 1984 to 2000, so the course of river is not the same as it was at that point in time. It was a rather linear and a straight river, and with passage of time it has become anestuizing and it has taken a typical meandering course. That means there is certain amount of oscillation which is also happening in north-south fashion. So when you see this particular area, this total span is about 100 kilometers. 100 kilometers. That means it is going from east to west, west to east, but it is also oscillating in north-south fashion. So that becomes a lateral zone of influence of Ganga River. So all those regions where it is actually oscillating and leaving these paleo channels or scars in between marks the delimiting boundary to the south. That means this portion consists of older alluvium. That means the provenance is different for this. But this zone actually is affected by this. So all these areas are highly infected with arsenic. These areas are highly infected with arsenic. And as you see, this portion, because of the pronounced levy formation here near Danapur camp, this portion is free of arsenic, right? So when you do any amount of sampling in Maner, you'll get very high values. And the BIS and the WHO standards is, if it is more than 10 ppb in water, then you have to consider it as anomalous and it is dangerous. Next slide. So ये हमने कुछ study किया था. I'm just showing it with the help of one slide because we need to be cautious when we dig water from around Maner area and particularly the banks of Son River. That these are some of the skyscrapers that you're seeing, and we try to do a control of the depth that was found. So in a particular aquifer depth of 14 meters to 58 meters was a zone which had maximum amount of arsenic, and that ranged up to 650 ppb in water. And the amount of samples were very high. You can see these skyscrapers. This is a sampling that has been carried out at various levels. Surface level, stagnant water, eutrophic lake conditions, subsurface well, shallow wells, deeper wells, all wells. And as you can see, these are the sampling points. And you can see particular depth of 14 meter to about 58 meter is the zone which is showing very high arsenic. And we do a depth diagram also. This is the zone of 20 to 75 meter, which is showing maximum amount of arsenic water. But you see the surface water is 11, that is zone of aeration, the incidences are very less. When we go to deeper aquifers, that means below 75 meter or 100 meters, we are not finding arsenic. So that means that there is a morphostratigraphic control, there is a particular age of sediments which is actually arresting all the arsenic. So that became our basis of investigation, and we did several studies after that, which I'll make it a formal part of my next presentation if I do. Next. These are some of the ramifications of arsenic. You need to be cautious about it. And obviously, it leads to life-threatening diseases as cancer also. Next. 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 Okay, these are some of the facts. That is groundwater assessment platform, 55% irrigation, 85% of rural, 55% urban needs. For Patna, the total annual groundwater recharge is 91,000 hectares per meter. Net annual replenishable groundwater resource is 82,731 hectares per meter, and the draft is equivalent to 47,000 hectares per meter. So we are still getting a buffer of about 40,000 hectares per meter, which we can say keeps us in good stead in terms of availability of groundwater. So the total draft is much less as compared to the total available resources that we have with us. But still, the stage of groundwater development, which is in a good portion, stays at about 58 to 60%. But it should be less than that so that we can, there are certain areas which are getting much more critical. I'll just show you with a map. And these are some of the other details. I'll just leave the presentation with you. The overexploited category areas, how many wells are there? It's about 5,000 dug wells are there, 27 to 30,000 shallow tube wells, and 308 deep tube wells. So can you imagine? So many wells are actually drafting water from underground conditions. There's absolutely no check in that. And these are the wells which are there in the in the database of the government. What about the individual home wells? I have got a tube well also. I have got a deep boring well also. At about 262 feet, I am drawing water from it. How sensitive I am in terms of drafting that water is absolutely my prerogative of looking at it. Nobody is keeping a check on me. But the moment I don't get that water from that particular zone, I have a tendency to go down to a deeper aquifer, even invest money, because there is no other source of water. I cannot go to Ganga River and take water from there and bring it to my home. So there must be a mechanism of water harvesting so that the pressure on that underground water is minimized to a great extent. Right? Next. Groundwater development, existing groundwater draft by net annual groundwater availability, and that is how the exact competition on a 5-yearly basis is done. On a 5-yearly program, and development presently lies at 62%, but that's to be improved. And these are some of the semi-critical, critical, as you were saying rightly, and there are some of the areas which actually lie in the critical area. Next slide, please. Now, if you see, these are the red portions which are actually the very, very critical areas, which have actually been saturated and they're not finding water at a reasonable depth. But all those blue areas are the areas where there is still scope for water. Water is quite there in the bucket, and the average of all that, the groundwater development is roughly falling around 60%, right? And these are the areas or the locations with the help of exploratory borders that have been investigated. Next slide. Next slide. So population density in aquifer zones. Next. Well, some of the figures, of course, I do collect a lot of articles from the newspaper or whatever excites me, because sometimes they provide very good information to substantiate your observation and data. So if you look at the records from 1870 to 2010, the effect of La Nina and El Nino effect and the drought and flood areas. Next, please. You see this particular zone, and which should actually make us take a stock of the situation. It's from 1980 to 2020. You can see there are more number of graphs which are going below the average line, right? And the flood portions is minimally reduced. There is only one spike over here and absolutely nothing after that, right? There's no, this is, I'm talking about the annual rate. When you talk of all the red spots that are actually after the average line of minus meters, it is actually going down. So you can see this depletion is quite conspicuous over a period of 40 years now. That's a big time. And 30 years is a good time for a weather condition or a climate to change in a particular region. So if there is a continuous shift of the climatic regime in the area, which we're completely seeing in our case also, then there is something to be worried about. Unless there is a drastic change in climatic conditions and we revert back to normal, which is quite unlikely. Now, even if you look at the population rise from 1901 to 2011, there has been a substantial increase. The kind of people who were dependent on groundwater was much less, but today the population has increased like anything. People are indiscriminately using groundwater resource as to meet their regular needs. Now you can see year-wise depletion of groundwater from 1996 to 2003. The line is self-explanatory. It cannot be more evident in terms of what it is trying to depict. This is depletion in meter, and it's continuously going down. Next. Whoa. Just look at this graph where we are actually matching with China in terms of population. It's not far. That in about 2030, the lines will cross, and then China are going to show a negative trend in terms of population increase. The worm will go down, but we will continue to increase if we are continuing the same manner. You can see that is the point where, now if you compare it to the giants of the nation, that is USA, China, and India, you can see at 1960 they stood at 66 crores, and China now stands at 138 crores. That is just double the population, right? And India stood at 45 crores. It is tripled in that very time at 133 or 135 crores. And USA stands doubled at 18 to 32 crores. That means the surface area available to them is much less. But in the limited surface area that we have, we are really multiplying, and the word is multiplying itself, right? So if this is one of the paper articles which was taken way back in 2019. But that is a very good picture of the areas which are actually deficient in rainfall in that particular annual season. As you can see, all the green areas are showing annual good rainfall. That is normal rainfall. I'm not saying normal rainfall, but of course they are showing a certain amount of reflection also. But the red areas are the portions which are largely deficient, and particularly the orange areas which are deficient. So you can see all the bhagwa colors are actually the deficient areas to the northern part, that is the desert conditions in Gujarat and Rajasthan, and particularly the east coastline district. That is Orissa, Chhattisgarh, Raipur, Bengal, and Tamil Nadu. All these portions are actually grappling with the problem of water. Next. So this is the present population, and it is constantly showing an increase. Next. Well, that was a gravity assessment data, ma'am. This was done by the Space Agency. Of course, this is a non-invasive method. And they try to see the changes in the Earth's gravity field and try to correlate it with the loss of water storage conditions that lie inside the Earth. And if you still, I showed this map towards the beginning also. The maximum dependency of population lies in the Indo-Gangetic Plain, and it is home to about 600 to 700 million. And probably the most heavily irrigated portions of the world. जितना irrigation यहाँ पे होता है, वहाँ इतना कहीं नहीं होता है. the GRACE satellite mission on the basis of this gravity study has clearly shown a large-scale mass loss that is clearly attributed to the excessive extraction of groundwater from that area. So they did a particular kind of study, which was later corroborated with other finding also, and this is done on a decadal basis. So in that zone that you can see flowing up to Pakistan, and wide is the portion which are the rivers which are in play. So there is a substantial decrease in the underground water conditions that have been found as a result of this GRACE mission. And the depletion has been to the extent of 54 to 108 kilometer cube per year. That is equivalent to 10 times the entire water that is lying in Diri Dam as a reservoir and all other surface structures of India and all other river bodies. So you can just imagine that continuously there is a decline in the Indo-Gangetic plain also. I'm not talking only about the peninsular India. Next. Now, this is a case study of Warangal and Anantapur district, and this is, of course, I took it from internet, but I found it to be very interesting in how this active participation from the community can make a difference. What happened in Warangal and Anantapur district, and particularly in Telangana and AP area, that is the Sugam, it's a privately owned organization, and they were helping the locals. And what the problem is that the annual precipitation was much less, about 450 millimeters per year, and even in the other district it was close to about 700 meters. So all the large ponds or the surface reservoirs have completely dried up. As a result of that, dry ही नहीं हुआ था, silt से उभर गया था. So that was very fertile, but the carrying capacity of the surface repository had decreased like anything. So these private companies came to me and they started helping the people. Now that is where the role of active participation comes. When the problem is faced by all, then only you will rise to the occasion. Otherwise, if one is relaxed and the other is not, it might not sensitize you as much, right? So what really happened is that they catered to about 12,000 population, and that was about 3,317 families in rejuvenating the desilting tanks. So what's it did out here? That these are large repositories of surface water, as we see in our village areas also, the bunds, that they cover it and they try to store water over there. So what they did was that it was completely filled with silt. So this was very fertile silt. What they did, they issued tokens to every person, and these people, with the help of tractors, started taking it to the place of the farmers where they needed it as a source of, sowing the seeds and vegetation purposes. And they had to pay certain royalty for that. And every time that token had to be issued to the local person, and that person, by that method, they were able to count how many trucks were actually able to take that amount of silt from there. As a result of that, that was only not the silt which was removed for that portion, but that was increased. So that was the part of the Sugam project. As a result of this, 39,000 cubic meters of silt was removed as a part of this process in about catering to a population of 12,000 people. Now, similarly, what they did, that they cleared about many desilting tanks like this, which actually acted as a reservoir. The second aspect, there were many small farm ponds, small structure, something like this. So what did they? So actually, they cleared the pond. So there was a certain amount of investment from the Sugam project. They invested about 12 lakh rupees, and there was participation from the local villagers also. They contributed about 8 lakh rupees. And they collected about 97 ponds with the help of stone pitching and making the concrete so that they can store structure. Similarly, all these open dug wells, which are completely dry, what they did, they tried to divert the surface runoff of the areas, and they tried to localize all the water which was earlier getting wasted, diverting it to these wells. As a result of that, this program really flourished well, and this was the condition which led to, in about 1 year's time, this gave to a very good agricultural produce in the area, and they could save water for at least 2-3 field seasons, for a season from there. So all these wells actually got filled up. So this was one of the success stories. Next. Next. Rainwater harvesting. We only talk about it, but we actually never do it. पटना में कितना है हमको तो नहीं मालूम है, but mechanism आजकल बन रहा है.
कहीं है सर, जैसे
कहीं है.
पटना यूनिवर्सिटी में भी बना है एक सर.
तो बहुत रहा है सरकार का.
हाँ.
सारी सरकारी बिल्डिंग में बनाई.
जी. जी. तो उसको मैकेनिज्म को पेश में लाने, बट हमारी आवश्यकता उतनी ज्यादा नहीं है, इसलिए हम उस पर शायद ज्यादा बहुत ज्यादा ध्यान नहीं देते हैं. बट इन अ नॉर्मल टेरेस, जिसमें बड़े-बड़े पेनिनसुलर एरिया में बहुत सारे बड़े मकान होते हैं, अगर 30 मीटर into 40 मीटर का आपका surface area है, we can store 50,000 liters of water. Only the mechanism should be in place. What is to be done? That water need not be wasted. There should be a sub-condition which costs about 25,000 to 30,000 rupees, and उसमें हम उसको divert करके पानी को whenever there is good precipitation or rainfall, we have to divert that water into the system. Of course, we cannot take that water because पानी हो सकता है कभी गंदा भी हो जाता है. So there is a filtering mechanism to it also, which is there. So the normal mathematics show that 1 square meter, if there is 1 millimeter of rainfall, that will create volume of 1 liter of water. Similarly, for a 1 acre land, if there is 1000 millimeter of rainfall, that will create about 4 lakh liter of water, 40 lakhs liter of water. So next slide. So it is very good mechanism that you are showing the surface. These are all sloping roofs. So water has a general tendency to go through its travel through its gradient, and then these are pipes which divert the water, and there is a section of gravel. There's granite pieces, and finally the charcoal, and finally the coarse sand. So this acts as a filter mechanism, and this diverts the water into the soak pit where you are actually collecting this water. And you will be amazed to know that they have a separate sewage pit, and they have a separate water storage pit also. So they collect water from it, and they have connected it through a charcoal, and then they draw directly water because it is all filtered now. And they directly take the rainwater and start drinking it, and it's absolutely pure. There's no problem absolutely. The only requisite over here is that before the rainy season, they completely clean the terrace so that whichever water is coming is clean and pure, and it is filtered through the mechanism that they're looking. And this is actually catering to the requirement. So they are not not at all depending on the groundwater resources, which is not available. They have no option, but they have to collect these kind of sources. Next. Well, soak pit recharging, very good phenomenon. आप लोग भी पढ़े होंगे इसके बारे में. Normally हम एक cubic meter का 1 meter by 1 meter by 1 meter का लेते हैं, और borewell इसका डाया रहता है 6 inches. We go down to a depth of 12 meters, and उसी तरह से हम उसको ballast से, brick ballast से, and finally we take some gravel also, which is validy, and finally उसमें jute pack लगा के उसको cover करते हैं. And जो भी गंदा पानी आ रहा है, if it is diverted to that section, it actually acts as the repository, and water has its own mechanism. It trickles into the filter system, and finally the water which is collected down below is pure water. Right? Next. There is a similar case story of Maharashtra. Of course, many big cinema stars and organizations came to be. Of course, that comes with community participation also, but that just should be there. People should be interested in making a change to their living. Only when they get interested, people will come forward and start helping them. If that drive is not there within you, then obviously people are not going to help you, because they try to see some results which is coming up as a result of that program, your initiatives, and then the help starts pouring in. Of course, that's also a success story in which this entire area, which was absolutely drought prone, was converted in a matter of 45 days, where the entire village got in place, and it was kind of a celebration, and they changed the entire paraphernalia. They got trained how to store the water mechanism, to store the water in place, and ultimately that led to an absolute green part, which was deserted as far as one sector of Maharashtra was concerned. And they enjoyed seeing water, and that happens. When you see water, you actually get so thrilled that it is something that you can see and touch. Otherwise, it is never an alternative to carry water from.
So this program from the watershed management.
Sorry? Watershed. Yes. Next. Okay, so this was it as far as giving an account of the groundwater resources of Patna is concerned. Of course, some related topics which was just done to make you aware of what is going on throughout India, and how we need to address the problem as geographers, as scientists, as geologists. And today you are seeing Ukraine and Russia fighting over some trivial issues. Not trivial, of course. Those are very good mine centers. Of course, there are some vested interest lying in there. There are other areas where people who are actually supporting them. But water is slowly turning out to be a commodity, which will lead to certain amount of fights between big nations. So we need to be careful about that. We need to be slightly more sensitive about that. So thank you very much. Now I'll request Mr. Abhishek to take up the groundwater assessment, and he'll take the mathematical computation part and how we do it, and how we have turned this into one of our publications which is going to be published.
Welcome to the respected chairperson. And a lot of portion already sir has covered, and small portion of water quality assessment of the groundwater I am going to cover here. Groundwater resources are mainly affected in this by the three major activities, like the industrial portion, the fertilizer what we use in the agriculture, and the urban and domestic uses what e-wastes are coming out. So generally ions are released into circulating groundwater due to various chemical processes between minerals of the rocks and infiltrate water. it is important to consider the mineralogy of the aquifer, as earlier the sir has rightly said. Here, we have three major contributing factors from which the groundwater can be affected. The first one is the industrial wastage. The second one is the agriculture activities. Like in the agriculture, we have used various chemical fertilizer. The third one is the urban and domestic waste. Drinking water quality assessment. The decision making based on water quality data is a crucial issue because number of parameters compromises its quality. But in general, for the calculation of the ground WQI, water quality indexing, we are trying to include the more than 15 parameters to calculate the WQI. There has been so many workers who have already worked since 1990, and there is a series of workers also doing this work in the future. Now coming to the WQI portion. WQI indicates the quality of water in terms of indexing number. It is only a mathematical expression to calculate whether the groundwater is suitable for drinking purpose or not, or if it is suitable, then where is the category where it lies. In the current study, we have done a pilot project, like sir said, that the parts of the Patna city we have covered in the 2018 to 2020 portion in the area, and we have included the 16 important parameters for the calculation. The water quality has been calculated using the standards of drinking water quality recommended by the various organizations like WHO, BIS, ICMR. The weighted arithmetic index method suggested by the Brown et al. 1972 has been included here. Now coming to the calculation part of the WQI. First we have calculated the quality rating, that is small q. Small q1 would be calculated by the VN. VN is the estimated value. Estimated value, what we are after collecting the sample, we are testing the groundwater. Groundwater on the basis of 100 parameter, like I have earlier said, that here we have included the 16 different parameters. The VN would be the estimated value of nth parameter, that right? And the Q1 will be the quality rating. SN. SN is the standard permissible limit of that particular parameter, and that will be suggested by the various organizations like WHO, BIS, ICMR, and they are updating time to time. Here we have included the 16 parameters, which are mostly represented our area, and which have the main impact of the city or the outskirts of the city. And on the basis of their impact on the area, we have to give the weightage. Like in the heavy metals, we have to give on the scale of 1 to 5 only, and that scale. And here you can see that heavy metals, we are the influencing parameter, what we have given to the higher weightage, to the what we are impacting more. Now, in the second portion, calculation of unit weight. Unit weight is calculated by K by Sn. K is the standard constant, which will be calculated by the 1 upon summation of 1 by Sn. Sn is the standard value of nth parameter, right? And S is standard parameter. And now, after calculating the K value, now we can calculate the unit weight of the each respective parameter. We are talking here only about the one spot, and likewise we have collected more than 70 spots of the locations, right? So after calculating the individual parameters unit weight, here we have calculated over here. Now on the basis of the calculation, after calculating the unit weight and relative weight, here we are going to calculate the WQI. WQI represents the summation of Qn multiplied by the Wn divided by Wn, summation of Wn. Here we are adopting the WQI range after M. Prasad et al. 2019. He suggested that if the WQI value come with, below the 50, then the groundwater would be the excellent. And likewise, good and poor. If the water WQI ranges goes beyond 100, that should be treated before drinking. That as he suggested. WQI index has been calculated here. 77 representative location in our study area. And here we are going to show as our Patna city, the parts of the pre-monsoon period in the 2018, we have covered the 72 G by 2 portion area. And in the 2019 pre-monsoon period, we have covered the 72 C by 14 area. And here we can see the more than 50 WQI value like Gopalganj and Fuliatul. And in the C by 14 area, we have got the more than 50 WQI value in the Sindri and Gurdutola area in the pre-monsoon period. Likewise, we have calculated the same portion in the post-monsoon. Here, in the post-monsoon period of 18 for the 72 G by 2, Gopalganj and Fuliatola showing or still showing the high value of WQI. And in the 72 C by 14 and the same Gurdutola, it shows that the groundwater is affecting whether it is post-monsoon or in the pre-monsoon. Because this, as the land use land cover map is shown by the sir, is that area is mainly covered by the small scale industry and the high agriculture land. Here is the we have calculated each location for the WQI portion in the pre-monsoon period for the 2018 and the post-monsoon, and likewise in the 2019 period also. And likewise here we have the category also. Most of the water lies in the excellent category except some locations. Here we have some concluding statement like water quality index map has been prepared in parts of district as we have already shown in 2018 and 20. These areas are likely to see an urban expansion, especially in the south and the southwestern portion of the Patna city, like a development program of 2031. The availability of potable groundwater at reasonable shallow depth will be play integral role. Like most of the population depend on the first level of aquifer. That's why here we are dealing with the first level of aquifer only. The region has surplus supply of groundwater, but their suitability has to be monitored regularly in the point of their availability or in the point of their quality. This study brings about an updated assessment of groundwater index as a part of geo-environmental assessment of Patna, which is now identified as a conductor for the smart city. This is all about the WQI. And if you have any query regarding the calculation part, you are okay, thank you.
सर बेस्ट क्वालिटी ऑफ वाटर किस स्टेट में मिलता है? बेस्ट क्वालिटी ऑफ वाटर
Best quality of water.
नहीं आप कितना गिन क्या होता है पानी में?
Primarily
क्वालिटी ऑफ डेप्थ में क्या रिलेशन?
क्वालिटी डेप्थ में है कि फिल्ट्रेशन प्रोसेस उतना चैनल से गुजरा है पानी।
आइडियल डेप्थ
आइडियल डेप्थ तो हमको जो इसी लेवल मिल रहा है फर्स्ट लेवल
हम बताएंगे वो एक्चुअली होता है क्या कि जब वाटर जो नीचे जाता है तो जो सॉइल है वो फिल्टर का काम करता है।
जैसा हम सोचते हैं
उतना फिल्टर मीडियम मिल जाएगा उसको, इसीलिए वाटर जितना डेप्थ मिल जाएगा।
पानी को हम क्यों हमने गंदा पानी लिया। आपने एक जो केस स्टडी देखा था उसमें हमने सॉइल वाटर लिया, उसको हमने ब्रिक बैलेस्ट ग्रेवल ग्रेनाइट का पोरस और उसमें एलएमपी मीडियम बीच में हमने उसको एक्विटाइड। तो जैसा हमारा कंस्ट्रक्शन रहता है उसी तरह से पानी उसके बीच से जैसे ही ट्रैवल करके धीरे धीरे पहुंचेगा दैट विल बी प्योर वाटर, और उस पानी को निकाल के उससे सीधे चापाकल से लेके पानी को यूज किया पीने के लिए। तो दैट मींस दैट वाटर दैट यू आर यूजिंग फ्रॉम अंडरग्राउंड इज मोस्टली वेरी फ्रेश। आप ट्यूबवेल से भी पानी निकालते हैं अपने घर में तो आप उसको ज्यादा ट्रीट करते हैं क्या? आप आरओ में क्या नहीं डालते हैं, आप तो मैक्सिमम बॉयल कर लेते हैं, गर्म पानी पी लेते हैं। पीने के लिए आप भले हाँ मानसून बहुत फ्रेश रहता है वो पानी। सो अंडरग्राउंड वाटर इज जनरली फ्रेश, वो बहुत ज्यादा गर्म अनलेस एंड अनटिल देयर इज अ मैकेनिज्म व्हिच इज अफेक्टिंग द रिजर्वोयर। ठीक है, अगर आर्सेनिक है जैसा मैंने आपको बताया, इसका सोर्स कुछ और हो सकता है, उसका सेडिमेंट सोर्स होता है। तो अगर वहां का लिथोलॉजी कॉन्स्टिट्यूशन कंट्रीब्यूट कर रहा है प्रॉब्लम को, देन यू नीड टू बी केयरफुल, तब आप असेसमेंट करिए। जितना आप एंथ्रोपोजेनिक कंट्रोल में रहेगा पानी, वो ज्यादा इफेक्टिव होने का चांस।
अगर हम लोग बोरिंग करते हैं तो ये कैसे हम लोग आइडेंटिफाई करेंगे कि यहाँ पर मिलेगा, ऊपर मिलेगा नहीं? बहुत बार ऐसा होता है कि बोरिंग करते हैं तो वहाँ पानी।
करेक्ट करेक्ट करेक्ट।
ये कैसे
देखिए उसका तो बहुत सारा मैकेनिज्म है। एक तो वाटर ट्रेस मैकेनिज्म भी होता है जो कि रैंडम मेथड से बहुत लोग उसको करता है नॉर्मल एक्विफर्स के लिए, बट जनरल आपके पास प्रोफाइल होता ही है जो कि एक्सप्लोरेटरी बोरवेल्स के थ्रू ही होता है। तो आपके पास पूरा डेटा है, आप अपनी जगह में करना चाहते हैं, वर्जिन एरिया में जाना चाहते हैं, देन यू विल हैव टू। मैंने आपको स्लाइड में बताया था हिस्टोरिकल पर्सपेक्टिव में 350 एक्सप्लोरेटरी बोरवेल्स हुए थे सॉफ्ट रेटा में, सॉफ्ट रेटा नॉट हार्ड रॉक, सॉफ्ट रेटा मतलब इट इंक्लूड्स एल्यूमिनियम। तो क्यों किया गया था? उसको चेक करने के लिए कि एक प्रोफाइल में एक सेक्शन में मिल रहा है कि नहीं। द सेक्शन आप यहां करेंगे, सडनली रैंडम कहीं और कर देंगे, द चांसेस दैट यू माइट मिस वाटर। उसी तरह से मॉर्फोस्ट्रैटिग्राफिक थिकनेस आपका एक जैसा नहीं है। पर्टिकुलर एक्विडाक्ट क्ले जोन जहां पे 9 मीटर है, एक जगह 60 मीटर भी हो गया, जो आपने ईस्ट वेस्ट सेक्शन में देखा था। तो यू हैव टू टेक दोस डीपर ट्यूबवेल्स इन ऑर्डर टू अंडरस्टैंड। आपको बीच का लिथोलॉजी जैसे ही सपोर्टिंग मिल जाएगा, व्हेन यू विल फाइंड सैंड एज अ रिपोर्टिटी, chances that you will find water. Of course, the sources need to be identified.
गैस के थ्रू भी तो find होगा।
एकदम कर सकते हैं।
सर आफ्टर 50 इयर्स क्या प्रेडिक्शन कर सकते हैं?
आपको तो हम बताएं कि जिस तरह से पॉपुलेशन इंक्रीज कर रहा है और 2030 में हम क्रॉस करेंगे चाइना को लाइन को, सो हमारा कंडीशन तो डेफिनेटली कम होता जाएगा अगर हम जल्दी कुछ नहीं किए।
क्या टेक्नोलॉजी सर?
हाँ?
न्यू टेक्नोलॉजी क्या क्या आ रहा है ग्राउंड को स्टोर करने, या फिर एक्सट्रीम कंडीशन क्या हो सकता है इसका? हम लोग जैसे कि 50 साल बाद भी ह्यूमन कंडीशन रहेगा, उस समय वाटर का अवेलेबिलिटी क्या रहेगा, उस समय वाटर कंडीशन क्या रहेगा, लोग क्या किस तरह से उस वाटर को कंजर्व करेंगे? क्या
देखिए ग्रेस डाटा से हम आपको ऑलरेडी बताएं कि हम मीटर में उसको हम मेजर करते हैं, ठीक है, रीजनल बेसिस में। तो पटना रीजन को खाली हम देखें तो 3.9 टू 4.1 मीटर, व्हिच इज क्वाइट हाई, ठीक है। 100 सेंटीमीटर मतलब 400 सेंटीमीटर का डिक्लाइन है, मतलब 4 मीटर का कॉलम आपको पानी यूनिवर्सली रीजनल लेवल पे खत्म हो चुका है। अब उसको रिप्लेनिश करने का क्या चांस है? आप खुद ही इसका जवाब बता सकते हैं। They are all fossil aquifers. आप नीचे परकुलेट मैकेनिज्म करके आज आप कितना भी पानी डाल दें, उस रिजर्वर को फीड नहीं करेगा। वो फीड करेगा जब तक कि आप बचाते हैं, तब आप 2050 अगर उसको ना छेड़ें, then you will still have availability of water, because the water that you are using at deeper aquifer actually belongs to an era which was beyond human age. बात समझ रहे हैं? मतलब 10,000 से 20,000 years के बीच का वो पानी भरा हुआ है वो पूरे सिस्टम में, और दैट इज बिकॉज ऑफ द कंटिन्यूइंग ग्लेशियर पीरियड, ठीक है। इतना बर्फ जमा, इतना बर्फ जो इंटरग्लेशियल पीरियड में निकला, तो वो पानी सब गलगल के आपका रिपोजिटरी बना। आज हम ऑलरेडी इंटर वार्मिंग पीरियड में, वी आर इन द वार्मिंग पीरियड ओनली, तो कंटिन्यूअसली हमारा पानी घटता जा रहा है, इवन ओशन लेवल पे भी। सो इफ यू आर नॉट प्रिजर्विंग वाटर, आप खुद ही समझ सकते हैं कि कम हो जाएगा।
क्या ऑप्शन बचते हैं?
कैसे
Saline water को purify करेंगे।
रिसर्च पॉइंट ऑफ व्यू से
Saline water को purify किया
हाँ सलाइन ब्रैकेट वाटर कर सकते हैं, बट देयर इज अ कॉस्टली मैकेनिज्म।
तो समय के साथ उसको चीपर किया जाएगा।
बिल्कुल किया जाएगा, लेकिन आप सुनिए ना, आप कितना भी करें कोई भी चीज को, इंसेंटिवाइज करें अपने तरीके को, बट जब तक कि आप नेचुरल सोर्सेज को नहीं रखेंगे अपने पास, तो इट विल ऑलवेज बी अ डिफिकल्ट प्रोसीजर। आप
आपका रेन वाटर होता है ना, उसको हार्वेस्ट करना, उसको सेव
जी
करना,
करना ही पड़ेगा उसको मैकेनिज्म को, और एंड प्रेसिपिटेशन इज समथिंग दैट इज नॉट गोइंग टू बी हिंडर्ड इन फ्यूचर। आप बिकॉज यू हैव ऑल्टरनेटिव्स, देयरफॉर यू आर नॉट रिजॉर्टिंग टू दैट मैकेनिज्म। अगर आप अपने पास रखने लगेंगे, एज आई सेड, 30 into 40 मीटर क्यूबिक एरिया, जिसमें कि अगर हम 1200 स्क्वायर मीटर में आप 50,000 लीटर्स कंजर्व कर सकते हैं। आप करना चाहें तो कर सकते हैं मैकेनिज्म। आपके पास इलेक्ट्रिसिटी का कम सोर्स है, हाइड्रो इलेक्ट्रिसिटी, थर्मल पावर इज ऑलमोस्ट एंडिंग, कोल रिजर्व्स हैव टू, नॉन फ्यूल एनर्जी में नॉन कोल खत्म हो रहा है, उसको आपको मतलब इजी मेथड्स ऑफ ये करना है। उसमें आपको सोलर एनर्जी, हर इस तरह के इंस्टीट्यूट में सोलर पैनल लग रहा है, उसको भी करने के लिए आपको करना पड़ेगा। आपको मजोस एरिया में मैग्नेटाइट मिल रहा है, but that is of a grade which is poor, 35 to 40%, but those futures are for those repositories are for future। आप उसको बेनिफिशिएट करके 60 डिग्री पे ला सकते हैं, मतलब 60% ग्रेड पे ला सकते हैं, जो कि स्टील इंडस्ट्री में यूज हो, बट उसके लिए मैकेनिज्म ज्यादा है। So we always have to look for resources where is it easily available at 55 or 60% grade। तो आप दूसरा मैकेनिज्म की तरफ मत जाइए। हमारा तो यही कहना होगा कि जो चीज है उसको बचाया जाए, उसको बचाया जाए। अगर ऐसा मैकेनिज्म गवर्नमेंट नहीं लाती है, तब दिक्कत होने वाली है, हो सकता है। बिकॉज हमने क्या देखा है, वी हैव सीन अ लाइफ टाइम ऑफ 70 to 80 years or maybe 100 years through our fathers, and through our next generation, right? यही हम देख रहे हैं. इसके पहले का तो हम कुछ नहीं जानते हैं. We only rely on data. So how can we predict the future where we are absolutely not contributing to? ठीक है. थोड़ा तो हम लोग को मेहनत करना पड़ेगा इस चीज के लिए. तेल भी खत्म हो रहा है. 116 रुपया तेल हो गया है. These all are finite sources. कब एक दिन खत्म हो जाएगा?
240.
तो तेल को कैसे करेंगे? धीरे धीरे आपका ग्रीन नंबर प्लेट वाला इलेक्ट्रिक कार्स आ गया है. उसमें आग भी लग रहा है, उसमें दिक्कत भी हो रहा है. बट योर रिजॉर्ट से तो आगे का कोई
अल्टरनेटिव नहीं है ना सर. तेल का अल्टरनेटिव हो सकता है.
हाँ, वही बता रहे हैं आप. तो थोड़ा सा मैडम ने नेदरलैंड का एग्जांपल दिया था. आप साउथ इंडिया के किसी भी डेक्कन ट्रैप एरिया में डिफिकल्ट चले जाइए, आपको खुद ही आँख खुल जाएगा. वहाँ 10 दिन रुक के आ जाइए. इतना राइट.
बहुत सारे कंजर्वेशन का
राइट. आप 10 दिन रह लीजिएगा, इतना तकलीफ होगा कि आपको आँख खुल जाएगा. आप अपने आप को सेव कर लीजिएगा.
सर तो सन का भी दिखाया जा रहा है कि हीट इंडेक्स कम होता है.
हाँ, सब ठीक है.
ये तो कम होता जा रहा है.
सॉरी,
कम होता जा रहा है.
डीप एक्विफर्स में मैडम आर्सेनिक कम मिला है नहीं. देखिए जितना भी वेस्टर्न कॉर्डिनेट है, एंडीज या रॉकीज है, आर्सेनिक का only affects the basin. उसका जो भी एक्सेंट्रेशन हो रहा है, there has to be a deep seated source. जो भी ऑक्यूलाइट सोर्स है, सर्पेंटाइन ग्रुप होता है, उसका क्रिस्टल स्ट्रक्चर में आर्सेनिक होता है. इस तरह से अगर ऊपर आ गया तो बात पूरा एक्विफर में स्प्रेड
हम ये कैसे डिटरमाइन करेंगे?
बिल्कुल डिसाइड करें. हम आपको बता सकते हैं. आप पटना रीजन में अगर किसी भी एरिया में कर रहे हैं, go to a depth which is more than 100 meters. Yes, yes, you are absolutely right.
पहले जिस हैंडपंप में आपने देखा इसमें
बिल्कुल हुआ है.
आने लगा है.
बिल्कुल हुआ है. बिल्कुल लैटरल माइग्रेशन हो रहा है, वर्टिकल माइग्रेशन हो रहा है. क्योंकि हमारा ग्रेवल का सिस्टम है, फॉल्टी सिस्टम ऑफ ट्यूबवेल्स है. अगर हम उसका क्ले कोटिंग देंगे, इम्परवियस बनाएंगे, तो वो लैटरली माइग्रेट हो जाएगा. वो इसलिए पहले नहीं हो रहा था बिकॉज हमको पहले पानी ज्यादा मात्रा में प्रेजेंट था, तो हम शैलो एक्विफर से मेरा काम चल जाता था. आज वो शैलो एक्विफर सूख रहा है, तो हम डीपर में जा रहे हैं. That means we are contaminating the shallow aquifer also and the deeper aquifer also.
ये बंगाल में ज्यादा
Madam, arsenic, so it is such an important topic in context to Bihar, and the kind of investigation or the perspective of investigation that we are doing, वो इतना अच्छा है in terms of arriving at the source of arsenic. And what is that morphostatic control where you can find arsenic and where you don't find arsenic, and what needs to be done in order to save ourselves from arsenic problem, it will be shown in that presentation. वो बहुत अच्छा रहेगा.
Just trying to collect some students
जी.
from the other university also, so that we have a good, amount of
जी,
completions.
जी.
So that will justify your.
Because only we as an organization, if we have done some work, then we are in a position to say authoritatively about a particular subject.
Yes.
Otherwise, if we have shallow information, we would not like to tell.
Shallow. Still now, that they were just giving shallow information,
नहीं.
which was not authentic,
हाँ.
not at all authentic.
हाँ.
And we were not believing that.
तो बल्कि हमने इंडियन इंस्टीट्यूट ऑफ टॉक्सिकोलॉजिकल रिसर्च से स्पीशीज स्टडीज भी कराया. वी हैव डन सम मॉडलिंग आल्सो, हाउ इट ट्रैवल्स, और इवन सेकेंडरी एनरिचमेंट कैसे होता है. वी ऑलवेज ट्राई टू सी द सोर्स एरिया, कि भाई वहां से अगर आर्सेनिक आ रहा है तो जो है सो वही सोर्स है. नो, देयर इज अ मेथोडोलॉजी ऑफ सेकेंडरी एनरिचमेंट आल्सो. A 10 ppb volume can actually become 50 ppb depending on the conditions. वो कैसे हो सकता है, वो किस कंडीशन में होता है, वो सब का भी हम लोगों ने रिसर्च किया. या मतलब उसको पता करने की कोशिश.
सॉल्यूट ट्रांसपोर्ट मॉडल.
तो उस पे हम लोगों ने we also try to prepare some air profiles of the major rivers which are carrying arsenic. यहाँ sediments ला रहे हैं जिसमें arsenic arrested है. Colloidal state में, adsorbed state में, clay state में, sand state में कैसे कैसे vary कर रहा है, उस सब के बारे में हम लोगों ने काम किया. तो we have a good amount of data. Population मतलब काफी ज़्यादा data है. Sampling data is much more. It is not sporadic. जी. Sampling population has to be more. It will not be biased. It will not be sporadic. Because जैसे शेखपुरा एरिया में फ्लोराइड के लिए मैडम हम लोग कर रहे थे, तो पीएचडी का कुछ हम लोग को गाइडिंग वैल्यूज मिला था. The sector is that 0.6 ppm to 1.5 ppm is the area where we actually need fluoride in our body. That is good for physiology and the metabolism of the body. But the moment it exceeds 1.5 ppm, तब आपका dental fluorosis होता है. So 1.5 to 4 ppm. 4 ppm to 10 ppm is the area where it leads to skeletal fluorosis. And after 10 ppm, if it is more than 10 ppm, parts per million in water, then it leads to cryptic fluorosis. that also depends on the malnutrition of the population who is actually taking that water. अगर वो already less consumed है या मतलब बहुत अच्छे से पोषण उनका नहीं हुआ है, तब उनको इफेक्ट उनपे ज्यादा होगा. आप बिलीव नहीं करेंगे मैम, हमारे पास कुछ 20 डेटा था PhD का, and none of the values were exceeding 2 ppm. एक शेखपुरा एरिया है 72G/13 में, वहां हम लोगों ने काम किया. We did in pre-monsoon, post-monsoon, month-wise हमने डेटा किया. तो values were going up to 12.7 ppm. Can you imagine? और मतलब consistent values, ऐसा नहीं कि एक मिल गया तो उससे पे हमने कुछ बता दिया. 10 ppm, 9 ppm, 8 ppm, 8.5 ppm मिला. पूरे एरिया को हमने सरफेस कंटूर ट्रैक्स से मार्क किया और उसको पूरा बताया, उसको वेल्स को पूरा हमने क्रॉस किया कि नहीं इसको मत लीजिए पानी या समझ. तो दैट वाज अ गुड हेल्प फॉर द स्टेट गवर्नमेंट टू रिएक्ट टू अ सिचुएशन. तो मतलब हम ऑल्टरनेटिव्स दे रहे हैं, बट वो कितना कारगर हो रहा है.
कॉलेज में हमारे सहयोगी हैं केमिस्ट्री के, वो उन्होंने नवादा में फ्लोरोसिस किया है. वहाँ पे नवादा में उन्होंने काम पाया है.
बिल्कुल नवादा है ना,
नवादा में उन्होंने पाया है. और उन्होंने फिर कुछ प्लांट्स और कुछ इस तरह की चीजें हैं उसको सप्लीमेंट किया है, तो इससे फ्लोरोसिस का थोड़ा
कुछ कमी हुई है.
तो हमको लगता है उस दिन उनको हम गाइड करेंगे, so that you know you can
ये तो
supplement some of these,
नाइट्रोजन फिक्सिंग प्लांट से भी कम होता है.
कम.
नाइट्रोजन फिक्सिंग प्लांट में
लेकिन ये सब जानते हैं बहुत ज्यादा कॉस्ट इंटेंसिव नहीं है. मतलब आप एक जगह लगा सकते हैं. देयर इज एक्चुअली CSIR approved mechanism which removes lead and arsenic from 1 lakh liter of water in just about 10 minutes. बट आप उसका कॉस्ट जानते हैं कितना है? इट्स ऑलमोस्ट 1 crore. आप उसको कितना जगह लगाएंगे एंड हाउ मेनी बेनिफिशियरीज आर देयर एक्चुअली जो आप उस पानी को पी रहे हैं. देयर आर अदर मैकेनिज्म्स आल्सो, बट फर्स्ट पीपल नीड टू बी मेड अवेयर कि आप पानी मत पीजिए, तब आप उनको ऑल्टरनेटिव बताएंगे भाई यहाँ से पीजिए. जब तक वो जानेंगे ही नहीं कि वो क्या है. दीस आर नॉट कलरलेस एलिमेंट्स. पानी में दिख भी नहीं रहा है. लेड तो आपको आयरन तो दिखेगा भी, that leaves a leaching effect or a brownish coating effect in the tumblers or containers whatever. arsenic तो दिखता ही नहीं है. पानी है बिल्कुल. आप ये पानी पी गए, इसमें arsenic था कि नहीं, I don't know. It only acts when it is taken on a sustained basis for a period of time. और इसी कारण से लोग बहुत ज्यादा हो रहे हैं. And the situation is even more grave in parts of West Bengal. So we have tried to see, जैसा आप बोले arsenic आ कहाँ से रहा है. So that's a completely an area of geological domain कि हमने उसको पूरा उसका synthesis करने का कोशिश किया कहाँ से आ रहा है, how it became a part of the Sewale system and how this hydrological divide came from the Himalayas. और फिर जो एक north south का ये बना वाटर डिवाइड बना, धीरे धीरे आपका इंडो गैंजेटिक प्लेन में होलोसीन सेगमेंट में कैसे आया और वो गंगा प्लेन में कैसे आके आप लोगों में आ रहा है. सो बहुत लंबा मैकेनिज्म है मैम जो कि हम लोगों ने मॉडल करके किया.
problem of arsenic is felt acutely in Bangladesh also.
यस यस यस.
जहाँ पे मैम वाटर एबंडेंस में वहाँ पे काफी ज्यादा आर्सेनिक, बांग्लादेश, बंगाल, बिहार,
जितना फोरलैंड बेसिन है आप पाकिस्तान में देखिए, ऑल अलोंग मेजर रिवर्स सिंध, सतलज, ब्यास, रावी, चेनाब, झेलम, जितनी प्राइमरी रिवर्स आ रहे हैं, they all have their source in Himalayas. Just think about it. The first impression gives you an indication कहाँ से आ रहा है, क्यों उस बेल्ट में आ रहा है. That means it is some source which is carrying it from a different region into a region which has absolutely no clue of arsenic. The problem doesn't lie in the underlying lithology. आपके पास तो एलुवियम है, अगर नीचे से आर्सेनिक आ रहा होता, अगर लिथोलॉजी कंट्रीब्यूटिंग सोर्स होता, तो आपको डीपर एलुवियम में भी मिलना चाहिए था. ओल्डर एलुवियम में क्यों नहीं मिलता है? Why this particular section of alluvium which belongs to the Holocene age? तो वो आया है कहीं से. That means the source happens to be somewhere else, right? So उसी चीज को हम लोगों ने पूरा किया and it was appreciated ma'am and we are coming up with a publication also. So chalo, thank you very much.
Yes, Pratik.
So, like to propose a vote of thanks. First of all, good afternoon, everyone, and respected chief guest, Mr. Professor Akhouri Bishwapriya, sir, for gracing us with your thought-provoking PPT presentation on groundwater sources, and we have got many facts which we didn't have to know, like how many projects, in fact, historically, like you have mentioned about the project Elephant, how it has started to get some of the insights, but not all together, you could say, yes. And later, you also tend to show some of the solutions also from South India, like Project Suction, and how they have they are dealing with the problems. But there they have the problem. We are not facing it right now. But I would say one of the quote of Mahatma Gandhi, there is in this world there is MLs for everyone's need, but not for everyone's speed. So right now we are in a position that we have to think what we are in a present scenario and how we are going to tackle this problem. And further moving on, I would also like to thank Abhishek sir for your assessment, groundwater assessment presentation, and I would like to thank Professor Poornima Shekhar ma'am, our director ma'am, for she always continues us to inspire with this kind of opportunity she gives.
Yes, I would like to
us.
say Madam is absolutely so energetic and she's been a source of encouragement for all of us. And we're so thankful to you, Madam, for having us here.
She always
You have always looked into the interest of the subject. Always.
She always continues to inspire us to work with a great zeal of dedication. And I also would like to thank our support team, Manish sir, Kanchan ma'am, Saad sir, and Pavan, and all of the staff, also the other staff, the teaming staff, Tulsi Bhaiya. And lastly, I would like to thank our fellow teammates, students who tend to listen. This was a very engaging session. So it was to and fro, like sir was asking questions, and we were thoroughly engaged into it. And it's been a great learning. Thank you.
Thank you very much.
I, Madam,